Can you confirm if I'm audible?
Yeah, you are audible.
Okay, thanks. I can even unmute participants, right?
Yeah, I'll do that.
Yeah, please give me that.
Awesome.
Sorry. Can anyone try to unmute themselves and speak? Any of the learners here?
Yes, sir.
Yeah.
Yes, sir.
Yes, sir.
Sir.
Yes, okay, great. All right, all right.
Yes, sir.
My name is Vicky Kumar Sharma. I'm your maths course instructor. So I'll be taking today's first live session. So I'll just give you a brief about how this live session goes. So in a week, we'll have a 3 live sessions. So first is very primary, like it's on activity session. And also like we cover some of the concepts and we even take up some practice assignment questions if we have time. And second type of session is something called solve with us. So wherein our students will participate with us and they will be solving along with us and they'll give the answers. And the next session will be like summary session or like a doubt clearing session again, something like this. Okay. So welcome everyone to the first session. So this is mostly on activity. So what I'll do is I have gone through the discussion forum and I have seen like most of you have doubt in activity questions, and also I've seen that you have a problem with some of the concept. So I think like these 4 topics, that is sets, then relations, like all these types of relations, and then functions, and some topics like, yeah, how is this relations different from functions. This itself will cover all the topic. So we'll try to cover as much as possible in today's session. So what we'll do is we'll first briefly go through the contents of this, like in the first half of our session. And in the next half of our session, we can go with our doubt clearing session. That will be like, we'll take up an activity questions and we'll see like then you'll be able to solve those questions or not. Okay. So now if I just open down for the questions to all of you, then it will be like very haphazard and then, you might not be able to answer. So just to bring everyone on the same page, I'll just give you briefly summarize what these topics are. Okay. Is that fine to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
So this is something I want to see. We are 300 of us here right now. So I want like of course, like if all of you will speak, then nobody will be able to focus, right? So what we can do is, though it will be interactive session, but we'll try to make it like, so it will be like one way mostly. Whenever I'll tell you to speak that time. Okay. So let's start with our first thing, that is set, right? Let me take that. So if you have already gone through the lectures, you would know what is sets. So basically a set is a collection of well-defined items, right? So that is something. So what I'm expecting is like you would have gone through the lectures and also you would have tried activity questions at least, and then you are attending this live session. So for those who haven't gone through those things, can also pay attention to this, because we are just giving a summary to all of these, right? So what is a set? A set is a collection of well-defined items, right? So if I say this is my set A, give me a minute.
मीटिंग का लिंक भेजिए.
Okay, so if I say set A is something like 1, 2, 3, 4. Now you see this is basically a set which contains a natural number from 1, 2, 3, 4, right? So this is all of us knows, but you know a set can also have, let me say this as A2. A set can also have other elements, like not just a collection of natural numbers, but it can be mixture of anything. Like let's say, you know, like 1, or let me say a pi. Then I can even give it some other items such as let's say a name of a person. Let's say, you know, let's say Richa. Something else, like you can say anything like a box, right, or anything, right? So this is something another way of denoting what set is. So basically a set is a collection of well-defined items, right? And here in the set the repetitions are not allowed. So I cannot write box 2 times. I cannot do this. I can just have box written 1 time, right? So this is something a set, right? Then, you know, in the set the order is not important. So you can write in any way. You can write this box here, and then you can write pi, or then you can write Richa, and then you can write 1. So you can, the order is really not matters in the set, right? How you write these elements, okay? So this is something, a brief about what set is. So now what do we mean by proper subset, and what do we mean by improper subset, or what do we simply mean by subset? Okay, so if I say A is a set and it contains an element, let's say 1, 2, 3, and 4. Okay. Now I have another set B and it contains an element 1, 2, 3. Okay. So now I can say that B is a subset of A. I can also write B is a proper subset of A. Now what do we really mean by this, right? So this is something called proper subset. And this notation is called basically improper subset. So this is basically an improper, or simply you can say it as a subset. All right. So what do we really mean? What is the difference between these two? Okay. So now when we say these things, this means it is strictly less than A. So now that means if I have to say this is my element of set A contains 1, 2, 3, 4, right? And elements of set B contains 1, 2, 3. Now you see this is strictly less than A, right? So that's why we can use this notation. But we can even give this notation for this two sets. It's just because this indicates this contains all these elements, but it can also have the other elements. So in other words, we can say it is lesser than or equals to A, right? So this is one understanding out of this which we can make. So this is a proper subset. Proper subset is strictly less than.
Sir, may I ask a question?
So, okay, let me finish this, then we can take up this, right? So let me finish this right now. We'll just finish one part of this and then I'll open for a question, okay? We'll finish the topic and then we'll take up a question, all right? So we understood what is a proper subset. So one way of saying is this is less than, B is less than A. And here what do we mean is B is lesser than or equals to A. So both the statements are right here, okay? So now if we understood with this, now if I have to write down another set, let's say I write set B as something called 1, 2, 3, and 5. So I cannot say here now that B is a subset of A, right? It's because this element 5 is not there in A. That's why I cannot say that B is a proper subset of A. Or I cannot even say this as well, right? B is strictly lesser than or equals to, or it's a improper subset of A. It's just because this element is not present in set A. This element 5 is not present in set A. Okay. So having known these two concepts, now let's go with, now if I have something called A is a subset of B and B is a subset of A. Okay. Now, if these two conditions are happening, this implies A should be equals to B. That means elements of set A is equals to elements of set B. Okay. So now this is something we can make and understand. So let's understand this. Now, if I say A is a subset of B, that means, okay, let's understand this. If this was the case, okay, if my set B is 1, 2, 3, and if my set A is 1, 2, 3, 4, can I say this A is a subset of B? I cannot say this, right? Because you see, you have another element called 4 here, right? So it is not a subset of this, right? So what we can do here is, we can introduce another element here, that is 4, and then we can, let's check this. Now you see this. Now can I say this? A is a subset of B? The answer is yes, right? Because it contains all these elements, isn't it? Now, is this condition also being satisfied here? So again, the answer is yes. So now what does this implies? It implies that A is equals to B, right? So if these two are happening, then only those two sets are being equal, right? So this is something known to us. Okay, now let's understand what do we mean by cardinality of sets. So generally cardinality of set is denoted something like this. Okay, so cardinality of set A is what? It's 4, right? Cardinality of set, if this was, let's say, up to n, what is the cardinality of B? It goes up to n, right? So cardinality of this is n. Okay, so this is something we understood what is cardinality. Now, what do we mean by power set, right? So let's understand what power set is. So basically, it is a set of all possible subsets of it. So I'll just write down that statement here. What do we mean by power set? So it is a set of all possible subsets of A. Subsets of set. Okay. So now you see, okay, let me take a smaller element here because this will take more time if I list them all. So if I have a set A 1, 2, 3, 4, okay, now I have to list down power set. So now it says it is a set of all possible subsets of A. Can you tell me what will be the all possible subsets of A? Can anyone here voluntarily?
From 0 to the all elements.
Yes, sir. Yes, sir.
From 0.
5, 1, 2,
Okay, okay. All right.
The set elements in A.
Second,
All right. I should have not asked rather. So let's say now I myself will listen. Okay. Okay. So maybe I can ask you randomly and give me the answer. So that way it will be good, right? All of you rather speaking here. So Riyan Ahmed, are you here?
yes, sir. Good morning, sir.
Yeah, very good morning. Can you tell me what are the power sets of A? Let me say
Yes,
that.
the power set will be the formula of the power set is 2 to the power n, and there is 3 elements in the set A. So it will be the 8 power set of this set. That is, number 1 is empty set.
Okay.
Second is 1. Next is 2. Next is 3, and another one is 1, 2, and then 2, 3, then 1, 3, and the last is 1, 2, and 3, which is 8 total 8 proper sets.
So very good. So yeah, you told it right. So now let's understand again. Thanks, Riyan. So what do we? Yeah. So what do we mean by power set here? So I'll just recall this. It is a set of all possible subset of a set. So now set is A here. Now we have to list down all possible subset of this. Now what will be the first possible subset of this? Can I write, if I create another subset, let's say B, if I write just simply element 1 here, is B a subset of A? Answer is yes, right? So likewise, how many we can create such set, right? So I can have another set called 1, 2. I can have another set called 1, 3, 1, 2, 3, and so on and so forth. I can even have collection of this like 1, 1, 2, right? So likewise, how many subsets can we create, right? So that is something called power set. Now a set which contains all possible subset of a set is a power set. Okay. So what is basically a cardinality of power set, right? So cardinality of power set is given by this formula, as Riyan told here. It's given as 2 to the power of n, where n is number of elements of a given set. Okay, all clear? So now this can be written as 2 to the, how many elements were there here? 3. So this is nothing but 8. Now you see, if I list down all those sets here, so you see the first set will be an empty set, then 1, 2, 3. So totally 4, 5, 6, 7, 8. So you got it, right? So this is how we list the power set. So basically power set is a set after all. All right. So now having known this, let's go with the next concept. Okay, so I'll take up some questions here. Like if you have doubt on sets here. Do any of you have doubt on sets? Yes. Sir. Somebody asked me. Yes.
Sir, I'm Chief. Good morning, sir.
Yeah, very good morning. Yes.
Sir, in the B set, power set, you have written null set 1, 2, and 3. The 1, 2, and 3 should be enclosed in brackets.
Yeah. Thanks for pointing that. Yes. You're right.
Sir, I have a doubt.
Yes.
Sir, I have.
Yes. I'll take another 2 doubts.
Sir, I'm audible.
Yes. Go ahead.
Sir, I have a doubt in empty set.
Can be,
you have doubt in empty set.
Can
yes,
be
sir. Actually, in lecture, sir told that a power set contain an empty set.
Yeah. That is what is here, right?
But he gave an example about that if a power set contain empty set, just because like a real world example, he told that a bird with 3 legs can be taken as an empty set because it actually doesn't exist. So can we take all those things that is not possible as an empty set?
Yeah. But you don't really have to list them all, right? Because in set what happens? Repetition is not allowed, right? So just one this thing is enough. Okay. So now I request all of you to mute yourself now. Now we'll go to the next. Yeah, you're welcome. So now we understood basics of sets. Now let's get into let's go to the relations then. All right. And see, now I know like most of you will have doubts here, and all that doubts cannot be cleared here. What you can do is let me finish all of this, and we'll try to take as much as doubts we can. Okay. Or like I myself will try to cover those things. If it is not happening in the sufficient time, post it in the forum, discussion forum, or like discourse, from where we are going to take those doubts. And you have further sessions as well coming, so you can get your doubts cleared there as well. Okay.
Excuse me, sir.
Yes.
Sir, I have a doubt. Can I ask you a question?
It's related to set.
Yes, sir.
Yeah. Please go ahead.
Sir, there is a topic in the last of the topics state, which is subset and binary numbers. So I am unable to understand this, sir. How is it possible to understand?
Binary numbers. What concepts of binary numbers you're not able to understand?
Sir, that is n-bit binary number, 3 bits. What is bits, sir? I'm not.
Okay, so we are not getting to that topic right now.
Yes, sir.
We will just stick on to the syllabus here, because if we get into that thing, we are going into more electrical sides, and that is something we don't really have to get into. But yes, bits in the sense you can understand it's a binary concept, right? So I'll just tell you what binary thing is here, because Cartesian products, it's basically you will have 2 elements, so you can understand that with a binary thing, but we are not getting much into that right now here. Okay, so yeah.
Is it audible?
Yeah, it is.
He means to say that in the video lecture, there was a comparison with the bit. So he's mentioning about that. When n-bit binary, for example, in a set 1, 2, 3, it means 3 bits. There was a comparison with bit in that lecture video. He's mentioning about that.
Okay, I got it. So, sir, what he meant to say is just an enlisting there. Like, okay, now if this is like set A 1, 2, 3. So what he meant was like 3 bit, it means 3 elements or something like that. Okay. We don't really have to get much into this. Okay. All right.
Okay, sir. Thank you. Yes, thank you, sir.
Okay. So let's move to the next one.
Sir.
See, I'll tell you one thing. I have set of things to do here, and if we take off every doubts on the very elementary concepts right now, we won't be able to cover much. Okay. So what I request is, I mean, if you still have doubt, put it in a forum. We'll take it from there. Okay. Now let's cover the other topics right now. Is that fine?
Sir, how can we access the discussion forum?
It's very, I mean, I think you have the access. You will see on your page, student page, you can see like, you have 4 options. Yeah. So you have a forum options there. You just click on that and go. Yeah, that's all. Okay, fine. So let's go with the next concept. Now, what do we mean by, like when I have a set A, and let's say I have element 1, 2, 3. Now I have set B, and I have another element, let's say 4, 5, 6. Okay. Now what I can do with these two sets, right? So we have seen, okay, we can just make a comparison. Is A is equals to B or not? Or is A is a subset of B, or B is a subset of A, or something like this. We can also do something A cross B, right? So this is something called Cartesian product. Okay. So A cross B means what? So if I list down these elements here, so if this is my set A, and if I write down 1, 2, 3 here, and if this is my element B, set B, and if I list those elements here, 4, 5, 6. So what does this A cross B says is, I'm mapping this one with all other elements. So that means if I have to write down this A cross B, so A cross B is another set, okay, wherein you will have elements from both A and B, and the order is very important. If I write A cross B, that means the element should be from A. The first element here should be from set A, and the second element will be from set B. Okay. So now, okay, I'll mute everyone. Okay. So now, as I told you, like the first element will be from set A. So now that can be from here. So now if I go with 1 to 4, so I can write 1, 4. What is the next possibility I can pair with? 1, 5. And what is the next? 1, 6. Likewise, I can do for 2. So it is going to be 2, 4, then 2, 5, and then 2, 6. Again, I can write down 3, 4, 3, 5, and 3, 6. So you see, basically A cross B is called as a Cartesian product of two sets, that is A cross B. So here what else matters is, here if you see these elements, now the first element, the order becomes very essential here, because here it says what? A cross B. So I have to take the element. Now this first element has to be from set A, and this second element has to be from set B. Okay. So now that is one understanding that we can make from here. Okay. So having known this, so I can say that A cross B is nothing but A comma B. It's basically a set where A belongs to set A and B belongs to set B. Write down B. B belongs to set B. This is something I can write. All right. So this is what it means. So A cross B is a set. Okay. And this is what you have to make sure. That is, the first element is from set A and the second element is from set B. Now I've listed all those elements. Now you see, some of you might get confusion here. Okay. So this is set A, then the order does not matter, right? So then yes, that is completely right. But I don't have to alter anything from inside this. But yes, you can arrange this in a way you want. You can write down first as this element, that is 3, 6, 3, 5. You can write down as 3, 4. So you can write it in any order, but you are not going to make changes here. You cannot write this as this element as 5, 3 here. Okay. So this is one rule that you have to keep it in your mind. All right. So that is something, a Cartesian product of A cross B. Now then, what do we mean by B cross A then? So again, by the definition, if we speak here, so this is going to be, again, so I can simply write this as, let me say this as X, Y, such that my X belongs to set B and Y belongs to set A. Okay. So this is something I can write. So all I have to do is just reverse this order from here. So now if I have to list those elements, So I can write this as 4, 1, 5, 1. I can write this as 6, 1, right? And then I can write this as 4, 2. So it's just this thing has been reversed. Now, if you see, now I have to take B here and then A here, and this is 4, 5, 6, and this is 1, 2, 3, right? So this is reversed completely. Now what I have to do here is just map the way we have did it earlier, right? So this is how we obtained B cross A. Now you might be curious, okay, so if this is A cross B, B cross A is also done, can we also write some set as, you know, like something like A cross B cross C? Then yes, even that is possible. And then it will be Cartesian product of 3 sets that time, okay? Can I also do this A cross A? Perfectly, right? You can do this as well. So this is Cartesian product of set A itself, right? So here, if I have to list those elements, so I can write that element as 1, 2, 3. So you see this is set A and this is again set A, and all I have to do is map this, right? So this is something we get. So 1, 1, then you get 1, 2, and then you get 1, 3, and so on and so forth, right? That is something you can get. Okay. So now this is something about Cartesian products of set. Okay. And we understood here the elements, that X and Y elements that is inside this, right? That becomes very essential, that you have to take the first element from here and second element from here. Okay. So that is something we have to keep in mind. All right. So having known this, let's
sir,
go
can
to,
you, sir,
yes.
can you show the example of A cross B cross A?
A cross B cross A. Okay, let's take it as A. Okay, so how does that look like? So that's going to be something like this. So this is A. What is my A? 1, 2, 3. This is 4, 5, 6, and this is going to be again A, right? So let's take it as 1, 2, 3. So how do you list these elements? So I'll take first of this. Okay, so I can take 1, 4, and then I can vary this. Let me vary all these 3. Okay. So that is something I can do. So I can write down as 1, and then you can write it as 1, 4, 2, and then you can write this as 1, 4, 3. Now this is, I'm done with this 4. Now I will not be varying this. Now I will be going to 5, and again I will map all these 3. Okay. Now same way I'll go to 6, and then I'll map with all these 3. Clear? Then I'll change the other one, that is this. I'll go with 4 again, and then I'll repeat this process, right? Okay. So can you tell me what is cardinality of A cross B here? I mean, just put it in the chat box. I'll just see you there. Don't speak, just, yes, yes. The answer is 9, right? So the cardinality of A cross B is 9. Okay. Now you see, this is my set, right? This is my set. A cross B is a set. Now, if I have to make a power set of this A cross B, right? So what will be the answer? What will be the power set of A cross B? Power
It will
set,
be the set of all subsets, right?
yeah, power set of A cross B. Just put it in the chat. We'll take it from there. All right. So it's going to be what? It's going to be 2 to the power of 3 times 3. So that's going to be 2 to the power of 9. So that is something, yes, yes, yes. I could see most of you giving this answer. All right, so it's nice. So this is something you have to understand over here, right? So power set of A cross B is 2 to the power of 3 cross 3. Now let's generalize this, okay? So now if I have set, let's say this is something I have up to, let's say it starts with 1, 2, 3 and dash, dash, dash up to M. And now I have this set something like, let's say another same thing. Yeah?
Excuse me, sir.
Yes, yes.
Can you please repeat about the power set of A cross B, sir? That I can understand. The power set.
Okay, okay. I'll tell you. I'll repeat again. So now I'm just trying to derive our formula from here. Okay. So power set, if you haven't understood power set, just go to this YouTube video again and just understand what that power set is. Just to give you an overview on this, power set is it's basically a set of all possible subset of a set. Now A cross B is a set, right? Now if A cross B is a set, how many elements do I have? I have 9 elements, right? And we know power set formula. What do we get? Power set formula is 2 to the power of n, where n was nothing but number of elements in our set. Now this is my set, right? how many elements do I have? I have 9 elements. So that's going to be 2 to the power of 9. I hope you got it now, right?
Yes,
Okay.
sir.
So now coming to this part, I'll come to, okay, I'll mute everyone again. Yes. Now let's understand again here. So how do we, this is kind of tedious task to always list all these elements and then find out what will be the power set of that, right? So what we can do over here is, always we know, okay, what is the cardinality of A cross B? We, as just discussed, A cross B is going to be cardinality of A times cardinality of B, right? So cardinality of A was, I mean, in the earlier case, it was 3 and cardinality in earlier case was 3. So 3 cross 3 made it 9. And therefore that 2 to the power of 9 was coming as the power set of A cross B, right? So now let's understand, if this is my set A, what is cardinality of set A? That is M. What is cardinality of set B? That is N, right? So now this is my set. A cross, okay, A cross B is a set and it contains how many elements? M times N, right? So it's basically contains M times N elements. So cardinality of my set is M times N. Now I know the power set formula. Power set of a set will have how many elements? 2 to the power of N. So that's going to be 2 to the power of, I can simply write this as this way, A cross B, cardinality of A cross B, or I can simply write this as 2 to the power of Mn, where M is the element in set A and N is the number of elements in set B. So this is about power set, and we understood what is Cartesian products, and we also understood, okay, what is a Cartesian product of 3 sets. Now let's try and understand what is relations. Okay.
Excuse me, sir.
Yes.
Sir, what is the power set of A cross B cross A?
Okay, so can you just list it down by yourself? So I told you power set of this thing is going to be A cross B cross A. So could you tell me what is the cardinality of your set A? It's going to be M. What is the cardinality of your set N? B, that is N. What is the cardinality of your set A? That is going to be
M.
Yeah, M. So this will be the case. Clear?
2 power 27.
Yeah.
Okay. What is it?
Okay, if that 3, if M and N is 3, then yes, that is right. Okay, great. So let's understand now what are the type of relations, and we'll finish that and we'll take up some activity questions. So not activity question, we'll have other concept to cover here. Okay, so now what do we mean by relations? So basically, relations are derived from a Cartesian products. Okay, so that is one understanding you have to make. Okay, so one thing we understood from there, what is a relation? A relations is basically derived from Cartesian products of a 2 sets. Now the set can be the same set itself. Now if I say set 1, 2, 3, right? And Cartesian product means A cross A I can write, right? So I can list down all those elements and we know how to list them out, right? All we have to do is just pair with each and all, right? So that is something you can do. Now, okay, so what is a formal definition? So I can just simply write down here relation. So you can take this, and I think most of you know this, but if you don't know, just take this. A relation is a subset of Cartesian product of set. So now if I have, let's say set A is 1, 2, 3, and if I say another set A is, let's say 4, 5, 6, then what is my relation? Relation is basically a subset of Cartesian product of A cross B. Now this is something a relation we get. Okay, so this is fine with us. All right, now if I do A cross B here and I say this is subset, so basically a relation is a subset of A cross B, right? So if I have let's say if my, again, so how many relations can I make out of, so how many relations will be possible? Can somebody put it in a chat and tell me, okay, how many relations can be possible from these 2 sets, A and B? Okay, I can see most of you giving answer as 9, 2 to the power of 9. So basically, you see, let's understand this, whether it is 2 to the power of 9 or it is 9. Okay. So now you see, this is my relation, and it's a subset of A cross B. Okay. So now A cross B is basically a set, right? And how many elements I have? I have 9 elements, right? Now this is my set, which contains 9 elements. And in a set, how many subsets we can create? We can create 2 to the power of that number of elements. So how many elements do I have here? 9. So it's 2 to the power of 9. So how many subsets I can create? I can create 2 to the power of 9. So that means how many relations I can make out of Cartesian product of two sets. So can I say it will be the power set of A cross B, cardinality of A cross B? Yes, right? So that many relations I can make, right? So that is something you have to understand right now. And see, I request all of you to give attention from the week 1 itself, because this is something we are not going to repeat again. So you have to pay attention right from the beginning here, because you don't have time for repeating these contents again, because you have so many contents in maths, actually, if you see. So, okay, so we understood how many relations we can make out of this, right? So it is basically 2 to the power of Cartesian product of that set. Okay, so now this is something we understood. What is a relation? We'll not get into what is a function. All right, so that is something we'll keep it for end if we have time. So let's understand what are the different types of relations then, right? So can I have this now? If okay, so in type of relations, you would have seen that topics to be covered. We covered this one. We understood what relations are. Now we'll go with all these. Okay, so now let's understand with this one. So we'll go with first reflexive relations. Okay, so what I have done for simplicity is I have already made some contents here, so we can just simply focus on this. So yes, I want you to give me answer. So don't really go into all this. I'll take you step by step here and we can understand these things. Okay, so let me just zoom this. Yeah, all right, so yeah, now
I think sir has lost connection.
Yeah. We are not able
Sir,
to hear
your
you.
screen has stopped sharing, sir.
I think we should wait for some time for sir to, come.
Yes, I think
Yeah,
connection.
wait for 5 minutes, we'll be back.
Yeah.
No.
is my voice audible right now?
No, it won't be
Sir, it's audible,
possible
sir.
because it's already 300. So
No,
now we
you
can
don't
see
worry
it.
about that. Okay, now it's clear.
Yes, sir.
Sir.
Yes, sir. You're
Okay.
okay.
Okay, so one thing, yeah, sure. Okay, thanks everyone. So now just I'll tell you what, since we know what is a relation. Now relation is basically a subset of Cartesian product of two sets, right? So two sets means, just for the simplicity, we are not taking A cross B, but we will be taking A cross A. Now A cross A is also a Cartesian product here. So just for simplicity, we'll be taking A cross A here. Okay. So now a relation R. Okay. So the definition is a relation R. So basically R is a relation on set A if A comma A belongs to R for all. This symbol is called for all A belongings to A. Now this is your reflexive relation. Okay, so make a note of this. A relation R is a relation on a set A if A cross if A comma A belongs to, if A comma A belongs to R for all A belonging to A, that means I have to make sure that this condition is happening. Okay. So for which, now let me say this is my set A and I have these elements 1, 2, 3. Maybe I'll take some different color. Yeah. So I have this 1, 2, 3. Okay. So now how did we get that relation? So now if you see here, this is A, and how are we getting this relation? So we are actually doing this A cross A here.
Once more.
Okay, I'll repeat this again. Yeah. So I'll just go with definition again. R is a relation on set A if A comma A belongs to R for all small a belongings to set A. Okay. So now we know that basically
What is this V cut?
Yeah, that
R
is
and
this is a mathematical notation. This means for
Almost
all.
उसके मन की special को వచ్చిన
Okay, I'll mute everyone again.
separate को వచ్చిన message है
Okay, so this means for all. So just make a practice of this mathematical notation. This means for all. Okay, for all A belongings to A. Now these relations, now you see R1, R2, R3, R4, whatever I have written here. Okay, it is derived from where? A cross A. Okay, so here basically all R is a subset of A cross A. Now we are fine. These relations are obtained from A cross A. Now you have to tell me, if you have already gone through the lectures, you would be able to tell me whether this relation, this R1 is a reflexive relation or not. Just put it in a chat box. I'll see from here. Yes. Okay. So most of you are telling it as an yes. Nice. So all right. So why? Because of this very definition given here, right? So R is a relation on a set A if this is happening for all A belongings to A. That means this is the must condition. It must have these elements. Now let's check your understanding with this. Okay, is this R2 a reflexive relation? Now I would like to check here. Okay. Yes, no, yes, no, yes, no. All right. So this is why here your concept will clear. Okay. I can see most of you giving answers here. Yes, no, yes, no. So again, like we can take it as 50-50 doubt here. So all right. So what does the definition says? R is a relation on set A if A comma A belongs to R for all A belongings to A. So all I have to make sure is this condition happening. So is that condition happening? Yes, it is happening. And it doesn't matter whatever elements I give, but I have to make sure these elements are again present in my A cross A, right? So now you see, I can list this, I can tell this yes, but I have to make sure that this is the must condition. This must be there in my relation for it to be reflexive relation. So this is yes, because this is what on a set A, if A comma A belongs to R for all A belongs to A. It does not say anything about this, right? So this is happening here, correct? So this is one thing we have to understand, okay? But I have to make sure that this condition is happening, right? For all it says, right? So this has to happen, all right? So now let's see, what about R3? I'll see your chat box and let me see how many of you give the answer here. Most of you say no. Okay.
No.
Okay, great. So yeah, the answer is no for this. And why no? Because I don't have 3 cross 3, 3,3. This element is not there in this relation. That is why this is not a reflexive relation. Because again, with very definition of this. So what does it says is, if I have set 1, 2, 3, then I must have 1, 1, 2, 2, and 3, 3 in my relation. I must have this. Apart from this, I can have another element. That is perfectly fine. That is what it says. Clear? So now this is reflexive relation. Okay, so what about R4? So again, I'll see chat box.
No. It's not reflexive.
Not reflexive.
Okay. Okay, so again, great. So why? Because I don't have 3, 3, right? For the same reason. That's all. Okay. So now I think all of you got it. And those who didn't get it, please.
Excuse me, sir.
Yes. Yes.
Sir, in R2, sir, why should 1 comma 3 come, sir? If it's given
It
A
is
comma A,
because
then
of,
it's in
yeah, I'll tell you. It's because of very definition of this reflexive
Cartesian
relation.
product,
It
sir.
just, it's 1 comma 3 will be there in the Cartesian product, right? A cross A. So you can have any other elements, but all I have to make sure is these elements are present in there. Okay. That is what I have to make sure. That's all. Clear?
Sir, I have a doubt. Can I ask?
Yeah.
The doubt is, suppose if this set A is equal to 1, 2, 3, belongs to 1, 2, 3. If it belongs to real numbers, then if the relation does not have all the real numbers in the reflexive order, then it will not be reflexive, right?
In the order, okay, let's say this is 1, 2, 3, 4, 5 up to, let's say, n.
Yes, then if R1 does not have all means like 1, 1, 2, 2, 3, 3 till n,
Exactly. Yes,
then it will not be reflexive.
Exactly.
Okay,
Right.
thank you.
You got this concept. Yeah, you're welcome. You got your concept. But it can have other elements as well, so that's not a problem. Okay.
Yes,
so
of
now
course,
let's
it can have other.
Okay, so now I'll check with your knowledge again. Now I have R5 here. Now I have elements 1, 1, 2, 2, 3, 3, and let's say I have 4, 4. Okay, and
Answer
this
is
relation
yes.
R5 is a subset of A cross A, right? Now tell me, is this, just put it in answer. Is this relation a reflexive relation?
No, it's not reflexive, sir.
No, sir.
It's not a relation, period.
Because 4, 4 it does not exist in the set A.
Exactly, right?
The element 4 does not exist.
Yeah, so you have to pay attention for that as well, right? So
Firstly,
most
it
of
needs
you,
to be a relation.
so I just wanted to highlight that
Maybe
thing. That
it's
is why
not
I
a
wrote here.
relation.
Yeah, exactly. It's not a relation.
R3 and R4.
Sorry.
So can you explain
R3
R3 and R4 again?
Okay, but I would advise you to watch this video again, because if we repeat some of, okay, just I'll tell you. See, because of this very definition here, it's given if A comma A belongs to R for all A belongings to A, right? So what we have to make sure is, if I have element 1, 2, 3, I have to make sure that 1, 1 is there, 2, 2 is there, 3, 3 is there. If I say, like, as someone pointed out, I don't know what is his good name, but if there are up to n elements, so I have to make sure there that n comma n, the last element, like this thing has to happen there. And apart from that, I can even have other elements as well. That is what it says, because there is no restriction on other elements, so I can have those elements. That's all we have to understand from it. Okay.
So when
Clear.
you say, so sir, when you say other elements, it should be available in that particular set, right? It
Yeah,
should not
exactly,
be.
exactly.
Okay. Thank you.
Yeah, you're welcome. So now let's go with this identity relation.
Sir,
okay. Yes.
Sir, suppose we have set A, which is 1, 3, 4, and set B, which is 6, 7, 8. Then there is no such relation which is reflexive, right?
Why?
Sir, because we have 1, 2, 3 in set A and 6, 7, 8 in set B.
Yeah.
Yeah. So the relations are from A to A cross B.
So yeah, so that is what one understanding you can make from here. But here, definitely you correctly pointed out, if you have set A and set B, and as per that definition, this is not happening, right? That is perfectly fine. Yeah. Okay, can we go to the identity relations now, and then we can discuss both of this?
One doubt, sir.
Sir, one doubt.
Okay. I'll come to that doubt. First, we'll take up this identity relation, and then we'll take up together. Okay.
Okay, sir.
Okay. So now let's go with identity relation here. Now it says what? A relation R again in a set A is said to be identity if this condition is happening. Okay. So it says what? X comma A for all X belongings to A. Now you have to understand here. Now this is one mathematical way of understanding it. But how do we comprehensively understand this? So in identity relation, I can only have elements. I can only have identity elements. That is these elements. Okay, and I cannot have other elements. That is what it means. Okay, so that is comprehensively you can understand this, because you see here it implicitly says that x comma x is basically identity relation. It's basically a set which contains only these element it contains. That's all, nothing other elements. So if you see that way, is R1 an identity relation? The answer is yes, because
Yes, sir.
Yes, sir.
yeah. So that is one thing we have to understand. Now, could you tell me what about R2?
No.
Not identity relation.
No, it's
Okay,
not.
okay. Now I want you to put your answers on the chat. Okay. So this is not, but this is yes. Why? Because I don't have 3,3. Okay. Because of that reason. Now what about R3? Come to R3.
No, it is not. Because 1, 3
Okay.
is there, and we cannot have any other than the same element.
Yeah.
It's reflexive, not identity.
So it's special. It's like a special case of reflexive relation.
Yeah. So can I say this?
Yes, sir. Proceed.
Yes, sir.
Yes. Sir, one
Right?
doubt.
So why
Sir,
not?
one doubt. Sir, if we have a set of 1, 2 Ram Shyam, then what to do in reflexive and identity relation?
Okay. Now you have set A.
Or set of
which
real number, integers.
1, 2, 3. Okay. Set of integers. So all you have to do is stick on to the definition. Now you would have gone through comprehensive sets will be given to you. Okay. So now wherein you will be knowing that you give a relation R and then you say it's a set of real number, right? So it's basically, if that is the case, then what do you have to make sure? Reflexive relation says what? Now you have to do R cross R in that. Now when you do R cross R, and if this is your relation, so when you say something like this, you have to understand that your relation contain all these elements, right? R cross R. Now if you see in that R cross R, you will definitely see these things coming up, correct? 1, 1, 2, 2, or let's say -1, -1. That is definite case happening, right? Right?
Hello, sir.
That is why that becomes an reflexive there, right? Okay.
Hello, sir.
So yes,
Sir,
yes.
I have one doubt, sir. Sir, I have one doubt, sir.
Okay.
Sir, could we say that reflexive relation is only possible when two sets are proper subsets?
Yeah, you can say that here.
Sir, I have
Sir,
one
can you
doubt.
scroll down a
You have
bit?
to make it.
Sir, I want
You
to
have
say
to.
that. Sir, I want to say that in identity relation, that I have to have all the combination of the same numbers, that is 1, 1, 2, 2, 3, 3 are likewise, and in that is means I have to have that in all the sets. I have to should be contained in the relation, or I can say that only 1, 1 and 3, 3 is there, so we can take it.
No, you have to make sure that this is happening for all.
All the same
so
number
basically you can
combination, like x and x should be same number, that is both from that same number only, right?
Yeah.
And if I change the
exactly.
combination, then it is no longer identity, it becomes reflexive.
Yeah, exactly.
So here
Again,
can we say that
Sir.
R1 and R1 becomes both identity and reflexive relation?
sorry?
Sir, can we say that R1 is both an identity and a reflexive relation also, sir?
Yeah. So you have
Yes.
it here. So you can
Sir.
address this, right? You can address this.
Sir, R2 is not reflexive, right?
No, but
Sir,
R3
if
is
R2 is
reflexive,
not.
but not identity.
Sir,
What about R3? Even R3 is not. Okay. So I'll mute you all. Again. This is again going, I mean, there are some
Sir.
students who are not sleeping, but who's trying to learn from here.
Sir, can I ask something?
Okay, we'll take up your doubts in the forum. Let us go with the further concepts here. All right?
So one thing, please.
Okay, fine. Go ahead.
Sir, why not, sir? Sir, in identity relation, it isn't mentioned that it is for all belonging to set A. Then why it is, sir, so R2 is not identity relation?
Okay, so you mean to say this thing, right?
Right, sir.
Okay.
So here it is mentioned for all X belongs to A.
So you can actually write down here also, okay, for all X belonging to A. And and this is, see here it was just a statement saying that for all X belongings to A. But here there was no restriction. But here you see this is set comprehension way they have told it here, right? But here we are not mentioning it in a set comprehension way, and it says clearly that all this x has to belongs to A definitely, and it can only
Right.
have these elements. Okay.
Yes,
Okay.
sir.
All right. Yeah. So
Okay, thank you,
now
sir.
you're welcome. So now we are done with this. Now let's try and understand the other concepts here. Okay, and then we'll switch on to the other concepts. I know most of you have many doubts, and I really sorry that I cannot take up all the doubts here because we won't be able to cover other topics, and eventually I'll have to leave these topics, right? So let's not do
Okay,
that.
understand,
If you
understand,
have
sir.
doubt, yeah, if you have doubt, put it in a forum. We'll take it from there. Okay. Or you can go to the other. I mean, of course, even that are I mean already structured like what to do. But definitely, what you can do is put it in a forum. We'll take it from there. All right.
Okay.
Okay.
So
So
I
now let's.
just one. Hello.
Yes. Yes. Yes.
So
Yes. Go ahead.
yeah. So I have I mean a doubt related to the assignment. So can I ask like, related to the sets, like, or what do you? I mean, how do you want me to do? Like, should I send it
Can
across
we
to the
take it?
forum? Yeah. I
Yeah.
mean,
Yeah. Yeah. Put it there. Put it there. Because right now what we are doing here is we are taking up all these concepts here, and if we have time, we'll take up those questions.
Okay.
Yeah.
Okay. So
Fine.
this was the question. Like, if possible, in this forum, or else like we can take it up later.
Yeah. Sure.
I have pasted the question. Okay. Thank you, sir.
You pasted the
Sir,
question.
I
Okay. Fine.
put question in chat box, please.
Okay, I
see
got
it.
your question. So this is practice assignment question, right?
Yeah.
So let
Yeah.
me complete this concept. Let me clear this concept, and I'm pretty sure that you'll be able to understand that concept afterwards. Okay.
Okay.
So no
Okay.
worries.
Thank
Let
you.
me finish this. All you have to do is that question is really lengthy, right? I mean,
Yeah.
we
Yeah.
have to really admit that. And
I'm able
because
to
of its
answer
length.
too, but the cardinality of R3, if you remember the question, only that is like little tricky. I'm not able to get it.
Okay, okay, I get your
Okay.
point.
Yeah.
But yeah, once you know this concept, all you have to do is just you have to list those elements. You will be able to understand. Okay. So
Okay.
there is,
Okay. I'll listen to the
yeah,
concept first. Then. Yeah.
yeah, yeah.
Okay,
Thank you.
understand,
All right.
understand.
Okay. So what do we mean by symmetric? So you have a concept something like symmetric relation, anti-symmetric relation, and asymmetric relation. So we have just made it here. So we can just simply go through what this is. Okay. So again, a relation R on set A is said to be symmetric if A comma B belongs to R, then B comma A should belongs to R. I mean, then B comma A should also belongs to R for it to be a symmetric relation. Okay. So now if this is my set A and it has an element 1, 2, 3, and again, these relations are from A cross A. So now what do you notice from here? So now it says what? If A comma B belongs to R, then B comma A should belongs to R, right? So now, yes. So could you tell me, is this relation R1 a symmetric relation? Put it in the chat box. I will
No,
see
sir.
it from there. Put it.
No, sir.
Okay, great. So I guess all of you know then what is symmetric relation. You might not have a problem, but you will have a problem when we are doing another thing. So let me just see how well you understand this. So you see here, why is this R1 not a symmetric relation? I'll mute everyone again. Okay. So now you see R1 is not a symmetric relation because it says if A comma B belongs to R, then B comma A should belongs to R, right? So if this A comma B is there, I must have B comma A here. So I don't have 2 comma A in the 2 comma 1 in this relation, right? And therefore this is not a symmetric relation. So just one thing will make it not a symmetric relation. Now let's go to R2. So is R2 a symmetric relation? Put it in a chat box. Yes, I think this is very obvious because if A comma B belongs to it, of course belongs to A, then B comma A also belongs to A, and you see basically B comma A also belongs to this relation, right? So this is what you see from here. So this is definitely a symmetric relation. So here, unlike what you have seen in other things, that is
Sir, how to?
Yes.
Please once more, sir.
Okay, let me finish this. We'll take up together your doubts. Okay, and I'm pretty sure you will have doubts. So let's understand this first. Okay, let me finish it. If your doubt gets cleared, it's well and good, right? If not, we'll take up. Okay, now let's go with R3.
Yes, sir.
Okay, now tell me, is this a symmetric relation? Put it in the chat box. R3. Yes, 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 no. Okay.
Yes, sir.
It is, right? Okay.
It
so
is
I'll mute again.
symmetric.
Yes.
Okay. So we'll just understand how for others who didn't understood. Okay. So now you see this is A comma B. Do I have B comma A in this? So I have it here, right? So this is definitely, this thing satisfies. Let's go with this. If this is A comma B, do I have B comma A here? So B comma A is here. So this also satisfies this condition. Let's go with this. If this is A comma B, do I have B comma A here? The answer is yes.
The same element
When
is
it's
B
not
comma
repeated,
A.
sir. Yes, the same element is B comma A. Okay. Now some of you might come up saying like, okay, why have you not written this 3 comma 3 again then? Right?
In sets, we don't repeat the elements again, isn't it?
Exactly. It's because, yeah, it's because of the same reason what you told right now. Because duplication is not allowed. Right? So you see the same element is, so basically I can say that, so I will use a word called something called diagonal element. So what is this diagonal element? So it's basically this elements. If both elements are same, I'll call them as a diagonal elements, just for our understanding purpose here. Okay. So now you see this diagonal element is symmetric in itself, right? So therefore this overall this becomes symmetric. Now you have to tell me about R4. Okay. Is R4 a symmetric relation?
No.
Okay, so most of you say no. Okay, definitely
No.
right. This is not a symmetric. Yeah, I got it. Okay, now let's go with R5, and then I give you another element 3 comma 3. Is this?
Yes.
Put it in the
Yes.
chat box.
Yes. Yes.
Yes.
Okay.
Yes, sir.
So, all right. So I see like you understood what is symmetric relation, but I'm pretty sure some of you will have doubt in symmetric relation after I complete symmetric and asymmetric. So let's understand this. I'll mute everyone again.
It can also be a.
Okay, so
Sir, can you
we
please
understood.
explain, sir, how 3 comma 3 is symmetric? Because it should be like A, I mean, A belongs to B, I mean, that way, right? So how come 3?
Okay. I just told here, but I'll repeat again. If A comma B is this, I must have B comma A, right? So you see this itself is B comma A, isn't it? So, isn't it?
Excuse me,
Can you
sir.
say-
So can you please repeat
Yeah.
the diagonal?
I cannot
relation
write
point?
this as, I cannot say 3 comma 3 again here. Why? Because this is set and it cannot have repetition, right? So that's why we write 3 cross, right? Okay, so somebody asked diagonal. So that is just simply, I'm using a word here. It is not like it's a definition or something. I'm just simply saying that if I'm writing 1 comma 1, consider this as a diagonal element. Okay. I'm just simply saying that because I want to give a certain word like 1 comma 1. If I want to say 2 comma 2, I want to say this element is a diagonal element. Why? Because these two elements are same. That's all. It's nowhere coming to your exam. It's just for our purpose.
Like in
Sir,
matrix.
Sir, then
Yeah,
can
yeah,
we
yeah.
generalize and say every identity relation is a symmetric relation?
Yes, we can
Okay,
say.
you will make that generalization afterwards, but let's first understand these concepts again. Okay, then we'll make generalization. Now let's go with anti-symmetric relation.
Hello, sir.
And here,
Ashutosh here.
yeah, hi Ashutosh.
So for symmetric relation, there should not be any condition like for all A and for all B.
Yeah. That is nothing here, right? In this definition, it just says if A comma B belongs to R, then B comma A should belongs to R. That's all. It's not for
that
all
condition is
elements.
there for the first thing only.
First two things, yeah.
Okay.
Sir, so
Okay.
can we say that A is equal to B?
Sorry?
Sir, so for R5 relation 3 comma 3, can we say that A is equal to B?
For R5?
3 comma 3.
3 comma
A
3.
is
Yes.
equal to
Mute
B.
everyone.
Yeah. A is equals to B. Yes. I'll do that. So yeah, definitely that is right, isn't it?
Sir, next 3 comma 3 answer correct?
All identity ones are.
So this 3 comma 3 is a symmetric relation. Like this. Okay. So let's go with the next one. That is anti-symmetric relation. Now pay attention to this concept. This is kind of important and most of you go wrong here. So now it says what? Again, the same thing, a relation R, the same way of writing a relation R on a set A is said to be antisymmetric relation if A comma B belongs to R. So there is an AND condition here, and B comma A belongs to R, then A should be equals to B. Okay. So now this is one definition. And I don't really advise you to go with this definition. And I want you to understand with this itself, the first one. Okay. So now it says what? If A comma B belongs to R, and so there is an AND condition. That means if this is also happening, that is B comma A is belongings to R is also happening, in that case, A has to be equals to B. Okay. So now I have made some examples here, and I'm pretty sure you will have doubts. That is why we have to go with multiple examples to understand these concepts here. Okay. So I have some examples here, like some 7, and we'll try to understand what is antisymmetric relation. Okay. Okay. So now you have, if some of you understood this concept, you're free to give me answer for this. Is R1 an antisymmetric relation? Put it in a chat box. Okay, most of you say no.
It's antisymmetric, sir.
Okay, at least somebody says it is antisymmetric. So basically, this is not an antisymmetric relation. So why? It's just because of this definition. If A comma B belongs to R and B comma A belongs to R, so this AND condition, if these two are happening, then only you will check for antisymmetric. If this condition is not fulfilling, then also it becomes an antisymmetric. That is also we have to take care of, and that you will understand eventually as we are doing it. Okay, again, I'll mute everyone. Okay, so now you have set A and it has elements.
One thing, sir.
Sir,
in R1, 2 comma 2.
I'll tell you. Okay, let me finish this. You will be able to understand all of it.
Sir, please repeat this definition.
Yeah, sure.
I didn't catch.
Yes, sir.
Okay. Now, if A comma B belongs to R and B comma A belongs to R, then A should be equals to B. That means I can write this R as, can I say that 2 comma 2? Can this satisfy this condition? The answer is yes. Why? Because see, if A comma B belongs to R, it does belongs to R, and B comma A belongs to R, it does belongs to R, then is A equals to B? The answer is yes. The answer is yes, it is. Now, let's try and understand with, I'll just mention it here itself and then we can go with those questions. Now, I have another relation R and I have another elements, let's say 1 comma 2, and then I have 2 comma 1, and then I have 1 comma 1 and I have 2 comma 2. Is this is this relation an antisymmetric relation? The answer is still no. I'll tell you why it is no. It is no. Okay, so I had this element 1 comma 1 and I had element 2 comma 2. Why? It is not an antisymmetric relation. It's just because you see this condition. If A comma B, if this is my AB, I have B comma A here, correct? So I have A comma B belongings to R and I have B comma A also belongings to R. Then it says what? If this two is happening, then A must be equals to B. Is A equals to B in this? The answer is no. That is why it is not an antisymmetric relation. Okay, so we will come to a generalization. I know most of you will be eager to generalize this, but we will come to this when we are done with all those examples. Okay, now I will have another relation. Yes, let me complete. I know you have doubt. Let me complete this. Now I have another relation, and in this relation, I have an element, let's say 1 comma 2. 1 comma 2. Now you must be wondering, okay, what is my set? So let's say your set is 1, 2, 3, and this relation is from A cross A. And now this. Is this an antisymmetric relation? The answer for this is yes.
Yes.
Why? I'll tell you why. It's because if A comma B belongs to R, okay, that belongs to R, is this AND condition fulfilling here? The answer is no. So if that is not happening, then it is an antisymmetric relation. So I'll repeat this again. I'll repeat this again. See, If A comma B belongs to R, if these two are happening, then I have to make sure this is a diagonal element. Okay. If I just have a single element, 1 comma 2, and I don't have 2 comma 1 here, right? So I'm not checking for this. So this AND condition is not being fulfilled for me. And therefore, I can safely say this, it is an antisymmetric relation. So this is one understanding you have to make from here. Okay. So having known this, I want you to give me answer for, I think you have already given the answer for R1. If you just see again here, so you see this is A comma B, and you see this is B comma A. Is A equals to B here? The answer is no, right? And therefore, this is not an antisymmetric relation. Now let's go with the next concept, R2. Can you tell me what about R2? Is this an antisymmetric relation?
No.
Just put it in a chat box.
No.
Put it in a chat box. Do not
Sir,
speak.
R2 it's correct.
R2 is not an antisymmetric relation. Why? If this is my A, then you see I have B comma A as well, right? Now what does my definition says? If these two conditions are happening, then A should be equals to B. Is my A equals to B here? The answer is no. Therefore, this is not an antisymmetric relation. I know most of you still have doubt. I will come to this. I will generalize this. No need to worry. Come to R3. Is R3 an antisymmetric relation? I think I already discussed on the top. But can you tell me this?
No, sir.
No.
No.
R3 is not an antisymmetric relation. And I will repeat this again. Why? You see, because of the very first definition. If A comma B belongs to R, B comma A belongs to R, then A should be equals to B. Is A equals to B? It does not say that A comma, that A comma B or A comma A should belongs to R or B comma B should belongs to R. It does not say this. It says that A should be equals to B, right?
Not correct.
So that is not happening here.
No.
Okay. Okay. What about R4? Can you tell me about R4?
Yes.
Okay. R4, yes.
Yes.
All right.
Diagonal.
Yeah. Correct answer.
R4 is
Yes,
symmetric and asymmetric at the same time. Can it possibly?
Okay. I'll come to that. We'll come to this. Okay. So as of now, you just tell me about antisymmetric. Is this an antisymmetric? The answer is yes. Most of you are telling yes. All right. Good. So why? It's because of the very reason. A comma B, and you see this itself is B comma A, right? If this is happening, then is A equals to B? The answer is yes. And therefore, the first element satisfies this condition. Similarly, this satisfies that condition. Okay. Now let's go with R5. R5. Yes.
Yes.
Put it in a chat box.
Yes.
Put it in a chat box. Put it in a chat box. I'll mute everyone.
Sir, can I say that antisymmetric is a sub?
Yeah. Can you R5? R5, most of you say yes. That's perfectly right. Okay. So you see R5 is an antisymmetric relation. It's because of very reason that A comma B, this itself is B comma A, and you see this A is equals to B, right? So that is happening. So this is perfectly antisymmetric relation. Now tell me about this. I think I already discussed R6. Is R6 an antisymmetric relation?
Yes.
Some of you still says no. So I'll just give you again recap to this.
Yes.
Hello,
Okay.
sir. Can I say one
Just
thing?
a minute. I'll take this. Let me complete this. I'll take this. Okay. I'll take your doubts. Now again, why? Because of this AND condition here. If A comma B belongs to R and B comma A belongs to R. So do I have B comma A here? I don't have it. So I'm not checking for its antisymmetric. So it is an antisymmetric relation. Right? Okay, clear? So this itself is yes.
How to R6 the value correct?
Okay, I got it. So now you say like see, when do you check for antisymmetric? So you have to first go with an assumption that it is an antisymmetric relation. First assumption. So if you are and when will your assumption go wrong, when this is going wrong, when this statement is going wrong, if you still have a doubt, if you still feel like okay, this is kind of difficult to understand, see there is an AND condition here. Says if A comma B belongs to R, and if this is happening, then itself you go for this. Otherwise, you don't go for this, right? Right?
Yes.
Sir,
Okay.
the second condition does it satisfy R6?
Yes, sir.
Yeah. If you are fine with second condition, definitely that is okay. I mean, so now let's go with R7. Is R7, I think
Yes.
most of you have already given answers here for
Yeah.
R7. So R7, you say yes. Yes, that is perfectly right. Why? Because you see, I have A comma B, but do I have B comma A here? I don't have it. I don't have 2 comma 1. Therefore, I'm not checking for whether A is equals to B, and this is perfectly fine. This is an antisymmetric. This is first case.
Hello,
this
sir.
case, right? Yeah, just give me a minute. Let me finish this. Now again, I'll go with this. A comma B. Do I have B comma A here? Answer is no. So I'm not checking for its antisymmetric, and therefore even this element is antisymmetric. You see, this relation becomes an antisymmetric relation. Okay. Now this is about antisymmetric. So yes.
Correct.
Okay.
Sir,
So now having known what is antisymmetric, let me go to what is asymmetric, and then we will summarize this. Okay.
Sir, asymmetric relation is not there in the course, right?
Asymmetric is not there in the course. Actually, see, since we are on the same page here, you have it symmetric, antisymmetric. So it's better to understand what is asymmetric here, because that might create confusion sometimes. Because you might come up with saying, okay, is opposite of symmetric is antisymmetric, right? So this kind of doubts comes on later on, right? So let's not get into those doubts right now. So let's go with this. What is asymmetric relation?
Excuse
right
me, sir.
Okay?
Excuse me, sir. Can you go over R7 of antisymmetric again?
Yeah. Okay, fine. I'll take you here again. You understood R6, right? Why is this an antisymmetric relation?
Very good. Right.
Because you don't have 2 comma 1 in this relation. You see, okay, why it is not, I'll tell you again. Because you don't have AND condition to check here. Now, if you see this is A comma B, I don't have B comma A here to check whether A is equals to B, right? Now I have A comma B. I don't have the other AND. Yeah, I'll tell you what is this AND condition. See, you check for antisymmetric if this is happening. If you have B comma A in this, if A comma B belongs to R and B comma A belongs to R, if these two are happening, then you check whether this is happening or not. Okay, clear? And let's say if I don't have this,
can you go with the AND condition? I'm not able to understand the AND
Sir,
condition.
can we say that
Yeah, same question.
antisymmetric relation
And
is
is
a subset of
not
symmetric
clear.
relation?
What is this AND condition?
Okay, fine. So now I will introduce
option 2. Option 2.
Option 2, yes. Option 2.
Okay. Now, okay, if you are not understanding with this AND condition, okay, fine. Let's go with this. If A comma B, this both definition is fine. You know, you can use any of these definitions. But since you are having problem with understanding with the very first definition, then let's go with the second one. It says if A comma B belongs to R and B A is not equals to B, then B comma A should not belongs to R. Now let's go with our R6. Okay, so I'll write down here R6. R6 element is 1 comma 2, right? So now you see if A comma B belongs to R, yes, it does. Is A not equals to B? You say yes, this is not, A is not equals to B. Then B comma A should not belongs to R. Is this also happening? I don't have B comma R, and therefore this is an antisymmetric. I think now it should be fine.
Part 2 is basically the same thing as part 1, the definition of antisymmetric.
Yeah. Now let's understand. Now that is something I give it as 1 comma 2. Now if I give it as something as 2 comma 2, okay, can you use this definition here? If A comma B belongs to R, yes, it does. And A is not equals to B. This AND condition is not satisfying here. So you will switch on to the very first definition. Okay. Okay. So now I will give you an idea. Okay. I will give you an idea. Okay. Wait. So when you see the diagonal, the word, what I told you earlier, diagonal element, right? So now if I say these diagonal elements, so that means if I'm using this A cross A things, right? So if I have these kind of things coming up, I'll be using first definition. And if that is not happening, I'll go with the another definition. That is when A is not equals to B. Okay. Okay, I think you still have doubts, but just to give you an idea on this, I will tell you what is this. See, first of all, I'll mute everyone again.
Sir, this means that a relation can be asymmetric and antisymmetric together.
We will generalize that later on. We'll generalize that. Okay, so now I will tell you which all relations are antisymmetric. Okay, so now you see if my set is 1, 2, 3, I'll just give you an idea again. And my relation are, I can only have these conditions. That means I can, if I have a diagonal element, then yes, diagonal elements are antisymmetric. Okay, my diagonal elements are antisymmetric. Now I just have one element, let's say 1, 2, right? This also is an antisymmetric. Why? Because of the second definition. Okay, now I have 1, 1. Okay, let me say 1, 1 and 1, 2. Is this an antisymmetric relation? The answer is yes. Why? Because this, I will use it because we know that, the very first condition it says, no? Okay, so I'll say like, okay, first definition and second definition. This is symmetric, antisymmetric because of first definition. This is antisymmetric because of second definition. Clear? Okay. Now I have 2, 3, and then I have 3, 2. Now I know this is not an antisymmetric, but which definition to use here? Okay. So now if I go with the first definition, and by first definition, we know that if this 2 is there, then I make sure that A is equals to B, right? And what about my second definition? It says that if A, B belongs to R and A is not equals to B. So you see here, A, B belongs to R. I'm using second definition. If you still have doubt in second definition, I'm using this. If A, B belongs to R and A is not equals to B, you see A is not equals to B, right? Then it says what? Then it said this should not be happening. That is B, A should not belongs to R. Does B, A does not belongs to R here?
It belongs.
No, sir. It belongs here, right?
It belongs.
It belongs.
Yeah.
It belongs there.
So it is not antisymmetric.
So you understood by both the definitions. So those who still did not get it, keep it in your mind here.
Yes.
All diagonal elements are antisymmetric. Okay. All diagonal elements. Now you might even have doubts. What do you mean? Is this an antisymmetric? The answer is yes. All diagonal elements, what I meant is, if you have any diagonal elements, that diagonal element in itself is antisymmetric. Okay. So keep that in your mind right now.
So can we say all identity relations are antisymmetric relations subset?
We will generalize that. Let me finish the other concept. We will generalize. Okay. So now let's go with asymmetric relations. Now, by now you would have understood that what is symmetric relation and antisymmetric relation, at least not all of you, but some of you, yes. Then what do we mean by asymmetric relation? Now it says, again, the very formal thing, relation R on set A is said to be asymmetric if A, B belongs to R, then B, A should not belongs to R. See, now that is something we have to understand. Yeah. So now let's understand this. Now you have been given set A here, okay, and your relation is from Cartesian product of A cross A, and I want you to give the answer for R1. Is R1 an asymmetric relation?
No. No, sir. No.
Put it in the chat box. Put it in the chat box.
Sir, please the A, B belongs to R, then B, A belongs to.
Should not belongs to R.
Not belongs to R, yeah.
Should not belongs to R. So if this is A, B
belongs
belonging to R, you see B, A belongs to R, right?
Okay, sir.
If it belongs to R, therefore it is not antisymmetric. Okay.
Okay,
now let's go with the next one. What about R2? All of you go with R2. Put it in a chat box. Let me see. R2, most of you say yes. Okay, I'll mute all again. R2, yes. Why? Because I have A, B and I don't have B, A here, right? And therefore this element satisfies the condition for antisymmetric. Now let's go with the second element. If A, B, do I have B, A here in this my relation? I don't have it. So what? I'll not be checking. So you see that is not happening here. right? It does not belong to R. Therefore, this is an asymmetric relation. Okay. What about R3? Put it for R3. R3. Most of you giving answer for R4 as well. Good. You
Yes, sir.
understood things then. Okay. R3. You see that 1, 2. Yes. Yes. Why? I don't have 2, 1. Isn't it? And therefore,
Yes.
this is an asymmetric. What about R4?
No.
No.
No, not.
No, sir.
No.
Why? Because I have A, B. Then you see this itself is B, A. And that should not be happening, right? Clear?
Yes.
Okay. So now we understood some things here. Okay. So now I have a question for you.
Sir, R4, please once more.
Asymmetric.
Yeah. Okay. I will take this one here and then I will give a quick recap like what we have done here. All right. So now you see, now you have to, in this, now you have a set A and I have a relation this. Now you have to tell me, you can, in a chat box, you can put it as 1, yes or no, 2, yes or no. So I will see that. So you have to tell me the first one. This is my 1, 2, 3, 4, 5. Now this is my relation. This is my set A and this relation is from A cross A. And then I want you to give answers in this way, like 1. If it is reflexive, then mention yes or no. Okay, I'll just say the chat box. Okay. Just for 1. I mean, most of you, okay. So 1 is reflexive. Okay, the answer is yes. What about 2? Okay, most of you say yes. 2 is yes, identity. What about 3? Is this symmetric?
Yes.
R3?
Yes. Yes, it's symmetric.
Yes, sir,
Except 5, all are yes.
Okay. What about, is this anti-symmetric?
Except by all.
R4?
Yes.
Yes, sir. Yo.
Only 5 is
Right,
yes.
It's also symmetric. But
Is
it
it
cannot
asymmetric?
be asymmetric.
No.
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 Okay, so now I will quickly take you through what is what, right? So we understood this now. So now just a quick summary. What is symmetric relation? It's basically symmetric relation says what? If A, A belongs to R, then B, A should belongs to R. If it is anti-symmetric, I will advise the first definition, and it is very good to understand with the first definition itself. If you go with the second, then yes. I mean, some of you are not able to understand why 1, 2 is anti-symmetric relation. It's just because of the second definition. Okay, just try and convince yourself why it is not, because you can use any of these definitions. Most advisable definition is this. Okay.
Sir, still
So
we are
Sir, why R4 is
Sir,
antisymmetric? Sir, why R4 is antisymmetric?
Okay, because of first definition.
Sir, once
If
please.
A, B belongs to
Example
R.
with name.
Explanation,
Okay,
please.
I will tell you. I will
Sir,
tell you.
please take example with name and number both.
Name and number.
Yes, sir. For example, 1, 2, 3 Ram and Sam and
Okay, I have my element 1. Then it can be, what's your good name?
Prem Kumar.
Okay, 1. Then you have Prem here in our set. Then you have, let's say, some Anna. Okay, or like let's take some another element here. Now I have okay, I can give it as, suggest me something like should I give a name?
A book.
Sir, I
Let me
think
take it as-
Prem wants to suggest that if set A is 1, 2, 3 and set B has 3 names, then what will be the relations between A to B? That's what he's asking, I guess.
Is it?
Yeah, I guess too.
Okay. So as if now, just stick on to this right now. We'll go to that complexity later on. So for time being, convinced with this. Okay.
Yeah, but I think the
Sir,
relation
why R4 is antisymmetric, sir? Please.
Okay,
Explain it.
R4 I will explain here.
R4
and
has
then
A,
we'll-
B and B, A both. Since A and B are same elements, but it is not compulsory that all the elements of A should be in R4.
Yeah.
That is the reason R4 is antisymmetric.
Yeah. There is no compulsion here, unlike the other two, that is identity and reflexive. Okay. So now do you still want me to tell R4? No, right?
Yes, sir, please.
No, I have got it.
Can we generalize the rule 1 as
Yes, sir. Yes, sir.
Okay, you tell me this. Basically, can I say this always happening, that anti-symmetric relation is a subset of symmetric relation? Can you give me answer in the chat box?
No.
Oh, sir. Sir, but if the anti-symmetric relation is subset of asymmetric.
Always not.
Sir.
Sometimes.
Yeah. Okay. What about the vice versa?
But sir, we can say identity relation is a subset of anti-symmetric
Yes.
relation.
It's
Okay. So we'll see that. We'll see that. Now
Yes,
this
sir.
is symmetric relation
Yes, sir.
is a subset of anti-symmetric. Can I say
yes.
this?
No.
Yeah.
Yes.
I cannot say. Okay. Okay. So
not for all cases.
actually, not for all cases, right? So now I'll tell you.
Yeah,
why
it's not
this
for
is
all
not the
cases.
Sir, not
So I
all.
take 1, 2, 3. Now I have, let's say, I have, my anti-symmetric relation should, not for all cases, because you can have a symmetric relation saying that, your R is something like this, that is 1, 2, and you have 2, 1. Right? You can have these elements as well, right, in your in your symmetric relation, but that is something won't be present in anti-symmetric, correct?
Yes.
Right?
Yes, sir.
Yes, sir. Yes, sir.
But I think anti-symmetric is a subset of symmetric relation. Can be?
No, not in all cases.
Again, that is not in all cases.
Not in all
So here-
cases.
yeah. So this is fine.
Sir, but
All right.
only one case will be the subset of symmetric.
Yeah, this is that case. That is the you have diagonal
First
elements.
case.
The word.
Yes.
Yeah.
Only diagonal elements.
All right. So this is fine. Now let's go with next concept. That is, now this is fine. I would suggest you, if you still have doubt, go to the same video, watch it again. You will not have any problem in that. If you still have problem, put it in a forum. We'll take from there. Okay. Let's take another thing. Now we understood this and this. Now let's go with
Function.
this definition. No, not function. You have transitive. So you have transitive relation here. Yes.
So in anti-symmetric, when do we say that we have to use the first definition or the second, or when do we use both?
Okay, so stick on to the first definition. Okay, so
Yes, sir.
where is that anti-symmetric? Yeah, here, right?
Sir, can we generalize the first rule as A, A belongs to?
Okay, we'll go there. But let me see with this anti-symmetric. When do you use this? See, you can actually use both the cases here, but give priority to this one. Whenever you have something like this happening, or just understand this, if this first definition is not being fulfilled, it is an anti-symmetric relation. If this condition is not being fulfilled, if these two conditions are not being fulfilled, it is an anti-symmetric relation. Simple.
Sir, I have a small question. Sir,
That is all.
what are the factors of 0?
Sorry?
Sir, what are the factors of 0? I mean, I want to know about 0 is composite or not.
What do you think, like 0 is? Can I write 0 times 1, 0 times 100?
0.
Yes.
Yes, sir.
0 only.
Every number
Yeah,
is a factor of 0.
Okay, but let's not get diverted from our topic right now here. Let's stick on to this again.
Yeah.
So what is transitive relation? Now, again, just stick on to the first definition, omit this. If, again, the same definition, if relation R on a set is said to be a relation R on a set said to be a transitive relation if A comma B belongs to R and B comma, see, there is an AND condition here. And B comma C belongs to R, then A should be equal, then A comma C should belongs to R. Okay, so I'll zoom this a bit. Okay, so now that is our first, we'll just stick on to this. So to all those who didn't understand that AND condition, so just keep in your mind, if this AND condition is not being fulfilled, then it is transitive. then you will not be checking for this, and that is that you have to take that as a transitive relation is right, or in another case there you would have seen an antisymmetric is right in that case. Okay, so now let's understand this again. Set A, this is from here, and then you have your relation R. Now you have to tell me this R1
Yes,
is an
Yes sir.
I'll see the chat box.
Sir, sir, आप बेस सही से हैं?
Sorry. Okay, I'll just take from the chat right now. All right, so can you tell me, is R1 an transitive relation? Answer is yes. Why? It's because now this is my A comma B. Do I have B comma A here? B comma C here? Then you see this is B comma C. So how do we understand what is B comma C? Like some of you might have doubt there as well, right? So when we write A comma B, right, it's just to indicate my first element is this and this is my another element. Now when I check for my B comma other element, I have to make sure my B starts with 2. Does this element starts with 2? No. So I will not be checking here. Does this element starts with 2? Yes. So this becomes my B. And what about this? This, the other element becomes B comma C, right? So this is my C. So now you have what? A is 1, B is 2. And what about your C? C is 3. Then these two conditions has been fulfilled, right? If A comma B belongs to R and B comma C is also belonging to R, then is A comma C belongs to R? That is something we have to check. So that is 1 comma 3 belongs to R here? The answer is yes, I have it here. And therefore, this becomes what? Okay, so this satisfies this condition of transitive relation. Now similarly, we'll check for the other one here. Now this is my A comma B. Now I will check with starting element as 3. That is, I have to check for B comma C, right? So I'll check here. Is this starting with 3? The answer is no. Is this starting with 3? The answer is no. Is this starting with 3? The answer is no. That means my AND condition is not being fulfilled. Therefore, this is also fulfilling the condition of my transitivity. Now let's go with the next one. This is my A comma B. Do I have B comma A here? Now B is what? 3. Now I have to check with 3. Is there a 3 here? I don't have 3. I don't have 3. Therefore, this AND condition is not being fulfilled. And this is this also fulfills the condition of transitivity relations. Therefore, this was fulfilling, this was also fulfilling, and this was also fulfilling. It makes it transitive relation. What about R2? R2, put it in a chat, I'll see. Let me complete this. Let me complete this transitive relation, and then we will take up doubts in this. All right. Yes, no, yes, no. Okay, so let's understand this. Again, let's stick on to our definition. What about my A comma B? A comma B is this 1 comma 1. Now I have to check with B element starting. Okay, let me finish this. I'll mute all again. Okay, now I'll check with B comma A. So now you see the first element, this itself is B. So this is B comma C then, right? So I have this thing happening, that is A comma B belongs to R, and then you see B comma C also belongs to R. Then what do I have to make sure? That A comma C should also belongs to R. So what is my A here? A was 1. What is B here? B is 1. What is my C here? C is also 1. Do I have A comma C here, which is nothing but 1 comma 1? The answer is yes, I have that, which is the same, right? So can I safely say that all diagonal elements, a diagonal element is a transitive relation? The answer is yes. I explained you why, right?
Yes,
So R2 is fine. What about R3? R3,
No.
put it for R3. Put it in the chat box. Is this a transitive relation?
Yes, sir.
Sir,
Yes, no, yes.
R3 is not transitive.
R3 is not transitive? Okay,
Yes,
we'll see.
it is
Not
Do
transitive.
pay attention to this and word here.
It is transitive.
It is transitive.
It is transitive, sir.
It is.
It is transitive.
Okay.
It is transitive.
Actually, you have doubt in this and, is it? Okay, so I'll mute again and I'll explain you why. Why is this a transitive? So you would have seen in antisymmetric relation. I'll tell you why R3 is a transitive relation, but why I'll explain you right now here. Okay, so now let's understand this. As I was telling you in antisymmetric relation, if this AND condition is not being fulfilled, I am not going to check for whether that is antisymmetric or not, and I will assume that antisymmetric. It is antisymmetric. Assume in the sense that is an antisymmetric. Okay. So now again same here. If A comma B belongs to R and B comma C belongs to R, I have A comma B. Do I have B comma C here? The answer is no.
No.
Right?
No.
I don't have B comma C, and therefore this is an this is a transitive relation. That's all. Okay.
So basically, in AND conditions, all the conditions need to be satisfied.
Both the condition has to be satisfied.
Yeah, I get it. Yes.
If you have these two, then you will have to check for this. If you don't have this one or like any of these, then you will say that it is transitive relation. Clear?
Yes, sir.
No, still not clear.
Sir, I'm not able to get it, sir.
Yes, sir.
Yes, sir, it's not clear.
Still not clear.
Not clear?
Sir, does R3
Yes, sir.
satisfies condition 2?
How can you say
Second
that one?
condition is not.
That is why the second condition is there when you don't understand with the first condition, this one.
It's not
similar
second,
to
right?
your
Second
antisymmetric. Yeah? Sorry?
Yeah,
Could you go
second
ahead again?
condition you can check.
Yeah,
then
second
that
condition is
condition
fulfilled.
R3 is transitive, no? Then
So if you don't get the first condition, go with the second condition and understand that. But I really don't insist on this. I would simply say that if this is there, let me repeat. Yeah.
Sir, if we take an example like 1, 2 and 1, 3, then second condition cannot be fulfilled truly. Like A, B is present in R and A,
it is
C
not
is not
transitive.
in R, then B, C, but it is transitive.
No, it is
But
not
second
transitive.
condition is not fulfilling.
Okay,
I
okay,
think
nice.
there is
Let's do this. Let's understand this. Now you have 1, 2 and 1, 3. Okay. So first we'll go with the first condition and we'll understand this. All right. If A, B belongs to R, okay. This is my A and this is my B. I don't have B, C here anywhere, right? I
Yes,
don't have
sir.
any
No.
element starting with 2, right? So I would say this is right. This is perfectly fine. What about this one? Let's go with this. This is A, B, right? And then you check for this. So do I have any element starting with 3 here? No. So I can safely say this is transitive as per my first definition. Let's understand the second definition as you had pointed out. Now if A, B belongs to R, that is A, B belongs to R, so that is there, and you have A, C, that is this is also there, then B, C should not belongs to R. Do I have here 2, 3? I don't have it. Since I don't have it, therefore this also satisfies that condition, right? I think your doubt is clear now.
Okay, sir. Yes, sir.
Yeah.
Sir, how R3 is transitive?
Yes, sir.
How R3 is transitive? Okay, I'll explain you.
Can I
Okay, I'll explain you with both definitions.
Yes.
Pay attention.
Sir,
I'll
please
explain you with both
repeat
definitions.
the second definition. 1,
Yes,
2
yes,
and
R2.
1, 3.
So can we
Okay,
say
you
that if AND condition is not fulfilled, then we won't proceed further?
And we will take that as transitive. Yes, you can say that.
Yes.
Achha.
And that's the catch here.
Sir,
Understood?
please repeat second
No,
condition.
sir, please repeat
1,
once again.
2 and
R3.
1, 3.
Okay, fine. So I'll take up again that example, what someone has pointed out here earlier, 1, 2 and 1, 3. Okay. With first definition, you are clear that this is
Yes,
a
sir. This is the
transitive.
second definition.
Okay. Now second definition. If A, B, what is my A? A, B belongs to R. So you see that what is A here? A is 1. What is B? 2.
2.
Clear?
Yeah.
Okay. Now you see AC and AC. So what is your A? So I have to check with elements starting with A, right? So of course this itself is, but I'll first take this one. So you will say that, okay, this is my A comma C, right?
C, yes,
Visually
yes,
this
sir.
is A comma C, right? So now
Blanks
what
to
is my C
blanks
here
to
then?
R.
C is my 3. Now
Yeah,
what
yeah.
I have to make sure this, B comma C does not belongs to R.
Not belongs to R.
2 comma 3 belongs to R here?
Yes.
It does not, no. It does not belong to
Excuse
R.
me, sir.
Sir,
Hello, sir.
Sorry.
2 comma 3 does not belongs to R, and therefore it is transitive relation. It says no, then 2
But
comma
A
3 should
comma
not belong
C
to R.
is belonging to R.
That is also.
Then
So it
Yes,
shouldn't
sir.
be in R.
It
I will tell you.
belongs.
Yeah.
So it is
Sir,
not transitive.
இப்போ நீங்க சொல்ற எல்லாமே பாசிட்டிவ்
Sir,
ரூல்ல
it is
belongs to
not
R லான்னு
transitive
சொல்றீங்க.
because yes.
sir, it
Sorry?
would be sir, it would be easy if you write in if else block as the program. You say that if first one is true and it is inside this, so instead of writing with and then, if you write if
I get
and if and then this is then not transitive. If anywhere
yeah.
false, then it will be transitive.
You know, that is
That
something
might help.
I thought. Yeah, that is something I thought too, but that is something again like what it was thought like. Yeah, somebody has given here as a truth table, but that is something left to the students to understand in their own way. But see, if I bring in CT here and then say like, okay, then it becomes a compulsion on student like, okay, you have to go and see that as well. So that is why. Okay, so I'll just give you an idea over here. Let's not
Excuse me,
stick
sir.
on to the second
Sir.
definition, and I'll just say the first definition and pay attention to this. Okay?
Hello, sir.
And yes.
Sir, by the definition, it is stated that A comma B belongs to R and A comma C does not belongs to R, as you written there.
Okay. Okay, so maybe it should be this case, right? Okay. Basically, like you can avoid this,
it would
but
be
I'm
easy if we go step by step. If first we'll check A comma B belongs to R. If it is there, then we will check B comma C belongs to R. And if both the conditions satisfied, then we will check A comma C does that belongs to R or not. If not, then we won't go further.
Yeah. Okay. So just go with the first definition. I'll just give you an summarize as you told it. If A comma B belongs to R, and if this is also happening, then I have to make sure this is happening. If this is happening and this is not happening, then I will not be checking for this, and it will still be a transitive relation. Okay, I'll repeat again. If this is happening and this is also happening in your relation, then I have to make sure that this is happening. Okay. If this is happening in my relation, if this is happening in my relation, yeah.
Second condition, we are going to correct it that A comma C belongs to R, right?
I need to check with this one. I'm not sure of this. You do not take this definition. Do not take this as definition. Okay.
So
I'm not sure of this. Yeah.
For R3, I am calculating like this. Suppose this 1 comma 2 belongs to R.
Okay.
And 2 comma 1 doesn't belongs to R. So I switch the condition and move to second condition and check.
Don't go with this definition right
yeah.
now.
Okay.
Okay. Don't go with this definition.
If that,
so
if
coming to this R3.
Yeah. Okay.
Yeah. Coming to this R3, I'll tell you why. Because of my second statement, what I was telling. If this is my AB, do I have B comma C here?
No.
Do this element start with B? I
No.
don't have to. I don't have this AND condition. When I go for this, when these two are happening.
Okay.
When this is only one is given, then it is transitive. Clear? Just keep it in your mind like that.
Yeah, got it. Thanks.
Okay, then what about R4?
Yeah.
It is transitive.
It is transitive.
It is transitive.
Because we understood from R1, yeah, we understood from R2, all are, I mean, your diagonal elements are transitive. So you give it any diagonal elements, all will be transitive. Okay.
Yes, correct.
What about this?
No.
No.
Not transitive.
Not transitive.
No, sir.
Not transitive.
No, sir.
Yes,
No.
transitive.
It should be transitive. Transitive. 2 comma 2 and 3 comma 2.
Yes.
So 2 comma 2 is already there. So 3 comma 2 is also there. So it is
Yes,
transitive.
sir. It is transitive.
It mixes up both the conditions, right?
No.
It shouldn't be. No.
Answer.
All right.
It shouldn't be.
I will mute everyone and then I'll explain this.
It is transitive, sir.
No,
Yeah.
it is
Transitive,
So
sir.
let's see why.
Transitive.
This is a diagonal element. Diagonal element in
Diagonal
itself
element.
makes it transitive. This is also there. Coming to this one, this is my A comma B. Now I'll have to check with all that elements starting with 2. So is this starting with 2? No. So I'll not be checking for this. Is this starting with 2? Yes. So I'll be checking for this. Right. So now you see if this is your B, then definitely this becomes your C, the other element of this. Then you see what your A is 3, B is 2, and what is your C? C is 2. Then does A comma C belongs to this relation? So A comma C is nothing but your 3 comma 2. Does that belongs to your relation? Yes, it belongs. It is the same element.
Yes,
Right?
that's why it's transitive.
And that's why this is there, this is transitive, and this also fulfills the condition for transitive. So overall, this is transitive. Now come to this R6. This is interesting.
Yes, transitive.
Not transitive.
Transitive.
Sir, it is
Yes.
100%
Okay, no, just give me the answer.
Transitive.
Not transitive.
Not transitive.
Transitive, sir.
It is transitive.
Okay, let's
It
not
is.
talk, but
It
just
is,
give it
sir.
here. Just put it in a chat. R6, R6. No. Why? Let's see that. Most of you say no, yes, no. Okay. Let's understand that. All right.
is transitive.
Sir, R5 again.
And equivalence.
R5 again.
It's not a transitive. R6.
R5 you see it again. I mean in the video. But I think it will get clear here in R6 itself. Now see, this is my A comma B. Right?
Oh, yeah.
Now I will be checking for B comma C here, right? So do I have A is 1, B is 2. Now I'll check, does this starts with 2? No. Does this starts with 2? Yes. So I'll be checking whether this makes it transitive or not. But you see any other thing starting with 2? Yes, this is also starting with 2. So I will have to check for that also whether it fulfills the condition or not. So first I will take these two pairs and then I will be taking another pair. So that means, so if I take this, then you see if this is my B, then this definitely becomes my C. So C is 3 here, right? So now I have to make sure that 1 comma 3 is there in my relation. Is 1 comma 3 in my relation?
Yeah.
Answer is yes. So it does satisfy for one case, but what about for other one? We'll go with this now. Now what is your C? What is your B here? It does starts with B. So this is my B comma C, right? Now you see that, do I have 1 comma 1 here in my relation? Because what is my C here? B is 2. What is your C here? C is 1. So then I must have, and A is 1. So I must have 1 comma 1. Do I have this?
No,
I don't have it. I don't have it, right? And therefore it does not becomes an transitive relation. So I will tell you again why this is not. Okay.
Just a second, sir. Sir, if one condition
not-
satisfies the transitive, but another condition, as you said, doesn't satisfy the transitive, then how
Then
can
it
we
is not a
decide that?
transitive. Then it is not a transitive.
What
Okay.
one condition is
In
Doesn't
a
matter.
set, all the ordered pairs must satisfy the transitive relation. Otherwise, it will not be transitive.
Yeah. All the ordered
Sir,
pairs.
our
Yeah,
we
yeah.
gonna take A and
As
B.
long as this is
Do
happening.
all the first element A and B.
Wait. As long as this is happening, I will have to make sure this is there. As long as these two are happening. Understand this. Okay? No.
Sir,
Still
second
no?
part
Should I
is
repeat
not
again?
important. Sir, second part of the definition, is it important?
No.
Sir,
Just
R6
do not
option
take
is
this.
correct, not
Do not
correct.
take Okay. So R6, you want me to repeat again?
Sir, in R6 you considered 1 comma
Yes, sir,
2
once again.
as A and B.
Okay, I will
Whereas
repeat
in
that.
R5 we considered 2 comma 2. Sir,
Sir,
ours
please
we gonna
repeat
consider
R6.
A and B, sir.
Okay, I will tell you that. Here, you know that diagonal elements is perfectly fine. It is transitive. It is also transitive. Coming to this part. This is A comma B. What is your A? A is 3. What is your B? B is 2. Now I will check all those pairs starting with 2. I mean, all those elements starting with 2. Is this starting with 2? No. So I'll not be checking here. Can this be my pair? Another pair? Yes. Can this be my pair? Is this starting with 2? No. So I just need to check for this, whether this makes it transitive. So what is my, if this is B, then this is definitely C, right? The other elements basically is C. So now what is my C here? 2 comma 2. Sorry, basically 2. So now I have to make sure 3 comma 2 is there in my relation. Is 3 comma 2 there in my relation? The answer is yes. So therefore that makes it transitive, because this 2 pair is the only one these two are the pair which is satisfying this, right? And that is why we are checking for this. If there are any other pairs, we will check for that as well. Keep that in your mind. Now see here, that is why this relation I brought in here. Now this is my A and this is my B. Let me complete it, then we will understand. Now A is 1, B is 2. Now I will check with all those elements starting with 2. Is this starting with 2? No, so I will not be checking for this. Is this starting with 2? The answer is yes, it is starting. So I got another pair. So this is 1, 2, and then I have 2, 3. So it's simple to say that if 1, 2 belongs to R, and now I have 2, 3 also belonging to R, right? Then I have to make sure what 1, 3 is there in my relation. Is this happening? Yes, it is happening. So one pair is satisfied, right? Now you see there is another element which can be your this, right? So this is B and this can be your C, right? So now this is going to be 2, 1 with the same. Now this is my another pair. First pair I took it and I checked it was satisfying the condition. It was being transitive. Now I'm taking these two pairs and I'm checking. Why am I doing that? Because I see that this is my B. If I had another elements which is starting with 2, I will be checking for that element as well. Okay. So now we will take this as B, C. Now you see that 2, 1. So also belongs to R. Then this must be happening, right? 1, 1 should belongs to R, right? So do I have 1, 1 here in this my relation? The answer is no. So that is not being, since these two are there, as per the definition, this must be there, right? But that is not there. So therefore, this is not a transitive relation.
Sir, we cannot use directly a second condition in 2, 1.
Do not bring second condition here.
Sir, is R3 not transitive?
R3 not transitive.
Sir, we can use third and the fourth element.
Third and the fourth?
2, 1 and 1, 3. So there is 2, 3.
No, but see, even if one violates your condition of transitivity, it is overall that relation is not a transitive relation. Clear?
Okay, sir. Thank you.
Yes, sir.
Yeah. All right. So this is about transitive relation. If you still have doubt, just watch this again. Somebody asked me again this one. I will go with the first definition only. It says what? If A, B belongs to R, and this AND condition is there, and B, C belongs to R. Do I have B, C here? This is my A, B. Do I have B, C? Do I have any element starting with B? I don't have it. Therefore, I will not be checking for other condition, and this will be your transitive relation. Okay, just take that. Clear? Now let's understand what equivalence relation is. So we have only 2 more minutes to finish this. So let's understand what equivalence relation is. Okay. So now if a relation which is transitive, symmetric and reflexive, if it is all of these, then it is an equivalence.
Please mute everyone.
Okay, now everyone has been put on mute. So equivalence relation. So a relation which is transitive and symmetric and reflexive, then it is an equivalence relation. So that is the condition. So if I give you a relation like 1, 2, 3, if I give you a set 1, 2, 3, and I have a relation something like this, now you tell me, is this relation an equivalence relation? Let me call it as R1. Put it in a chat box. Let me see how many of you can answer this. Okay, most of you say no. Okay, so first of all, as I told you, equivalence, when can a relation be an equivalence relation? A relation is an equivalence relation if it is transitive, symmetric, and reflexive. If all these three is happening, then only it will be an equivalence relation. So first, let's check whether it is reflexive or not. Okay.
Yeah.
So now I have 1, 2, 3. I have this thing also there. 1, 1, 2, 2, and 3, 3. Yes, it is perfectly fine. And it's okay to have other elements in reflexive, right? It's not identity case. What about symmetric? Is this symmetric? This is definitely symmetric in itself. This is also.
It is definitely symmetric.
Yeah. So diagonal elements are definitely symmetric. What about 2, 3? Do I have 3, 2 here?
No, so it's cannot be symmetric.
Not symmetric.
It is not symmetric. Okay. Okay. So if any of these condition is not fulfilled, it is not an equivalence relation. But just for the practice purpose, is this a transitive relation?
Yes.
Yes, it is transitive.
Yes, sir.
I know this is transitive, this is transitive, this is transitive, right? This element makes in itself. What about this one, 2, 3? So if this is A, B, I will check all that element starting with 3. Does this start with 3? No, so I will not be checking with this. This cannot be my pair. This also cannot be my pair.
3, 3 will be the pair.
And this also cannot be its own pair, right? So this is the other case. So if this is my B, then this is the other element definitely becomes your C. So C is nothing but 3. So then I must have what? I must have 2, 3 in my relation, and you see,
and that is there.
I have it.
Yes, sir.
And
That is there.
Yes, sir.
Yes,
right?
sir.
So this
2,
becomes
1 is not there. That's why it's not transitive.
Sorry, it is transitive.
It is transitive. All the elements satisfying transitivity. So it's transitive.
Sir, if we take 2, 3 and 1, 1.
2,
Sir,
3?
and 1, 1 in this relation.
We cannot take those two elements. They are not related in any way.
We cannot relate it.
Sir, please
Okay,
take
so
Not
example.
separate, not separately.
Okay, 1 minute. Just give it time.
Sir, not
If
separately.
this is the okay, in this itself, you want me to introduce here?
Sir, I'm Sonali.
Yeah.
Sir, I'm telling that in this relation R1, not separately, but if for checking transitive, if we take 2, 3 and 1, 1, then sir, can you please write? Sir,
2, 3.
if you take 2, 3 and 1, 1, then A is 2 and B is 3.
Yeah. So A is 2, B is 3. Yes.
And if you take 1, 1, then C is 1.
1, 1. Why will you take?
Okay, sir. I understood.
No,
we
you
can't.
can't.
Yes, sir. We can't take. Okay, sir.
Okay. All right.
Yes.
Okay. So now this is about equivalence relation. All right. So
Yes,
I think
sir.
we are done with all type of relations.
Sir,
And
please
Sir,
I
this
think
is
we are
equivalence or
one
not?
name and number.
Just a second.
This is not. This is not. This is not. Why?
Ah.
Because this is not symmetric.
Sir, please take
Oh,
example of
symmetry.
name and number.
Sorry.
Please
Sir,
take
how
example of
can
name and
we-
number.
Another number you want? Okay. Let me take another number.
Sir, name and number. Example.
Name and number.
Yes.
Name and number.
Yes,
Okay.
sir.
1.
Sir, if we go by this, A, C becomes 1, 3, no, sir, which is not present in the relation. Sir, how can we get it as transitive?
Sorry. Could you repeat again?
Sir, here we had taken 2 as A and 3 as B. So we are gonna
You
get
have taken. This is
2
A
as
and this is B.
yes, sir. And we are gonna get B, C as 3, 3.
Okay.
Sir,
Then you must have 2, 3 in your relation for it to be transitive. Do you have that? Yes,
yes,
you
sir.
have it.
Yes.
The same element, right?
Sir, can you hear me?
Yeah.
Sir, actually in the above one R6.
R6. Okay, first I'll mute everyone and then you unmute yourself and speak. Okay. Yes. Unmute yourself and speak. Yeah.
Yes, sir. In R6, if we take 2, 1 as A, B.
2, 1. Okay.
And if we take 1, 3 as B, C.
Yes, I can take this as B, C.
1, 3.
Oh, sorry. 1, 3. Yeah. Okay. This is my B, C.
Then A, C, 2, 3 will come, no, sir. No, sir.
So now understand this. So here you don't have to prove it, right? Even if one pair is making it wrong, therefore it is still not a transitive. All the pair has to be transitive.
Okay.
Understood?
Okay, sir.
Yeah. Even if one violates it, it is not a transitive. Clear? Okay. So I think it's time's up right now. But if you can stay with me for some more time, I can take up the other topics as well.
Sir, please
And
take a name and number example.
Sorry?
Sir, can
Sir,
you
please take
find
example with name and number.
Yeah. I get your point. Yeah, you were telling me again and again. So if I take A, what was your name? Prem, right? Okay. Now I have a relation. Now my relation contain element Prem, comma 1. Okay. And then I have another 1, comma book. And then I have Prem, comma book. Can you tell me this relation is a transitive relation? Can you tell me this?
Comma B, B, comma C. C.
Yeah, transitive.
Yes, sir, it is
Yes,
transitive.
sir.
Yes, sir.
Yes.
Yes.
Yes, you got it, Prem?
Yes.
Yes, sir.
Yeah. Okay, clear then.
Yes,
All right. So now let's go with the other thing. So see, this is like those whoever want to leave, they can leave right now. But if you want to stay
Sir,
with
I
me
have
for
a
some
doubt.
more
Sir,
time, we
can you
do.
give
Yeah.
5 minutes break, sir?
Actually, it's time's up. We can wind up the session right now.
Sir, I have a doubt.
We will stay, sir. Sir, you please continue. We will stay.
Sir, yes, sir, you can continue.
Yes,
Yes,
sir. Please
yes,
continue.
yes.
Sir, in the
Continue.
video
we will
lecture,
continue.
continue, sir. Continue, sir.
Okay, let me
Sir, in
finish
video
this.
lecture,
Stop.
continue, sir. Sir,
Yes.
sir, in video lecture, sir said that equivalence relation is a discrete value type something.
What discrete values?
Sir, they said that it
Equivalent
made
classes.
have a discrete values.
Okay. Discrete values means some values are listed here. Now, if I say, it's basically like you have two forms, right? Like one is set notation, and you can describe your set in set comprehensive, and you can say another as
In roster form, sir.
Yeah, in a roster form or something. So one is discrete values means you have a concrete values. I mean, some values are given to you. What do you mean by continuous values then? Something which is you give the range, okay, like this is the range or something, right?
Okay, sir.
Yeah, so those are not of interest here right now. So do you want me to take these things, or anyways the session is done, you can leave this session and
Yes, sir.
done.
Continue, sir. Sir, continue.
Continue. Continue all topics, sir.
Sir, please continue.
Relation and equivalence. We have to complete this.
Continue, sir.
Sorry?
Continue, sir.
Please
In
continue,
evening class,
sir.
we will solve questions.
Okay, I'll take right now.
Just one question.
Sir, will you please say equivalence class? Explain.
So both
Equivalence
are
class.
same, na? Equivalence.
Maybe that we can take it some other time, or like maybe like in the next session or something. Yeah, that is fine.
Class doubt.
But that is of no
Sir,
importance.
please,
There
class
won't
doubt.
be any
Daily.
question on equivalence class, so no need to worry. Okay.
Sir, I have a doubt.
Yeah,
Sir,
yeah.
please, sir, please wait. Daily attendance
Go ahead.
following daily attendance.
Yeah, you're welcome. So what daily attendance means? I didn't get you.
Yeah. Daily attendance.
Sure.
Daily
No, it is.
following students.
It's your wish. If you want to come, you can come. If you already know this concept, you don't need to come. Right?
May I please know?
There is no compulsion on you to attend this session. There is nothing like that. If you know already concepts, it's well and good.
Okay.
If you want to learn something, you can join us here.
Okay.
But yes, we will be discussing some of the concepts which will be really essential. And if you are fine with all that, you can do by yourself. It's well and good. But this is like very elementary thing we are doing right now here, isn't it? But as the session goes on, we will build up the complexities. But if you feel like you can do it by yourself, it's not mandatory. But yes, this will be a learning process. I mean, a learning session wherein you can come and learn with us. Okay.
Sir,
so
every week,
yes.
is it Thursday that the live sessions are coming, or is it may vary
for
in
maths?
different days?
Yeah, every week. Thursday, Saturday, and Tuesday.
Sir, please tell me.
I am learning Tamil. I don't know right now.
Okay.
But I am fine with Hindi.
Hindi, sir.
Yeah. All right. So shall we go with the next topic? Right? I
Sir,
think
may I know that
please.
on which
Yes, sir,
days are
please
live
continue.
sessions, which subject available?
Sorry.
Sir,
on which what?
On which day means is it Thursday or every week that live sessions are available?
Thursday,
guys,
then you have
we
it
have
on
a
Saturday and Tuesday. So Thursday morning 9:30, Saturday also morning 9:30, and Tuesday I think it's in the evening. It's 5 to 7.
guys for
This
this
is
we
for
have a
maths only. This is for maths only.
and they have sent the mail with the Google Calendar. You can just sync
you
with the
can
Google
just
Calendar
exactly.
and do that.
Yeah,
let's continue. We
Sir,
can't
give the PDF of this.
for everyone.
And then please,
PDF.
sir,
Let
go
it
ahead.
all.
Sir. Please, sir.
Please,
Otherwise,
I'll just stop all of you. I mean, I'll mute all of you and
yes,
I'll take
yes.
it.
Sir, I don't know why
Yes,
everyone
please,
asking
sir.
focus questions when
Yes,
everyone has
yes,
got
interview.
calendar.
Yeah, all right. So now let's focus again. I think we have taken already 5 minutes of break, right? So now let's go understand what is function, what is this one function, what is this onto function, and some topics like what is difference between relations and functions. This is anyways done. So yeah. So but yeah, before going to functions, I would first tell you what is a function and how is this function different from a relation. And if you are good enough with graphings, or see this, I'll tell you, this course of maths, it's since it is an application based, so we'll be dealing extensively with the graphs. Okay, so first week you don't have a graph right now, but I promise you, like if you attend all these sessions like this, you will be, by end of the day, you will be able to do all kind of graphics. So right now, that is about graphics, but let's stick on to what a function is, right? So let's start with function. So how is this function different from other things like relation, right? So what was relation? We learned that relation is basically a subset of Cartesian product of two sets, right? So that is something we learned, isn't it? So what is basically a function? So if I say, I will use a arrow diagram to explain this, okay? So there are two conditions which you have to, so basically a function is a relation with certain constraints. So I'll repeat again, a function is basically a relation, and you can say that a function is a subset of a relation, okay, but not a vice versa. So how is this function different from a relation? Okay, so now if I have element, let's say this is my set A and this is my set B, and I have elements 1, 2, 3, 4, and in set B I have another elements, let's say 1, 2, 3, 4, let it be 1, 2, 3, 4 only, 1, 2, 3, 4. Okay, so now when can a function,
Okay.
Yeah. So when can this
Yeah.
be a function? Now if I have to map, I was free to say that a relation was like I can map this with this, this with this, and this with this. I was free to do all that, right? And then I can do mapping from this, and similarly this.
So when each and every function element of A will have an image in element B.
Yeah, that is right. So first condition is all these elements which are there in my set A should be mapped with some element with B. Okay. So now if I say this, is this a function? The answer is yes, it is.
Yes.
Why?
Yeah.
Because all my elements of A has been mapped with the elements of B. Okay. Now that is one condition. So there are two conditions. And I'll mention these conditions here. You pay attention to this. First condition is all elements of set A should have an image, an unique image.
Sir, because all they are in codomain.
Yeah, no, we'll come to that. Domain, codomain,
Sir,
everything.
please
All
mute
elements
them.
of set A have an unique image in
Let me explain this.
set B. Okay. So now this is my set. So it says all element of set A. So that means I have to make sure that all elements have been mapped. Okay. So that is one thing. So now, is this an unique image? This is not an unique image.
No.
This is not happening.
Sir, it is onto relation.
We'll come to that.
yes.
Wait. Is this an unique image?
No.
Yes.
Yes.
Yes, it is.
Yes, yes.
Yeah.
Because two has got an unique image as one. One has got an unique image as one. Right? But you see, when 2 has 2 images, like this is not a unique image. It is giving me 2 images in set B, right?
Yes.
So
Yes, sir.
this is when these things are happening. This is not a function.
Yes, sir. One-to-many relationship.
So now you understand this. Now when you have, I'll say this, all elements of set A should have an unique image in set B for it to be function, for a relation to be a function. Okay, clear? Okay, so now this is about pictorially. Now let me draw a simple graph and let's understand this. All right. So now if I have a graph something like this, okay, let me say it is a straight line, something line like this, and this is my y-axis and this is my x-axis, okay, and I have a straight line like this, okay. So now what do we mean by this when we bring a Cartesian here?
Sir, please mute everyone.
Always, yeah.
So I wanted to request.
Yeah, I have muted them all.
Sir,
So now
everyone who knows
understand
the answer to be quiet and let sir explain, because if they talk in middle, it will be confusing.
Yeah.
The ones who
I
are knowing
understand.
answers.
And also
those
those of you who
Sir,
know
can you
this,
please put on mute to everyone? It's very
yeah,
noisy.
I actually does that, but you can unmute yourself and speak. So I think again all of you are muted.
Sir,
Do not
don't keep
unmute
the option. Don't keep the option, sir.
until no, but I want you to interact with me, no. So that is also needed. So anyways.
So we can interact through the chat box. It's very messy.
Yes.
Yes, when
Okay,
we
so
are hearing sound.
those who are here.
Sir, those who want to ask doubt, they can raise their hand.
Yes, sir.
Yeah, please.
Actually
Sir.
already, so okay, yeah, you can do that. All right, so just pay attention now. So now see, this is this is our x and y axis, and this is a line, okay, and now I'll just try to map with this arrow diagram here, okay. So now you see this set, this is my set A, which contains element 1 2 3 4, and this is another set which contains another same element. Now you understood how this function, how we can get these functions from a relation, right? When we satisfy those two conditions. So this thing is generally called as domain, okay, and this thing is generally called as codomain, okay. And on number line, this x-axis is called as domain, and this y-axis values is called as a codomain, okay. So this is the two things we have to understand. Then what is range? So range is, I'll show you here in this pictorial diagram. Now if this goes 1 to 1, 2 to 1, 3 to 1, and 4 to 1. So as per my condition of function, all elements of A should have a unique image in set B. So do you see that? A has a unique image 1, 2 has a unique image 1, 3 has a unique image 1, 4 has a unique image 1, right? So you see what? This is definitely a function. This is definitely a function because it is satisfying my condition. Now, but what are the elements in my codomain? Elements in my codomain is 1, 2, 3, 4. And what are the elements in my domain? You see 1, 2, 3, 4. Then what is range? So range is all those values in codomain, right? All those values in codomain. So now you see here, the range is only 1. Why? Because only this has got a pre-image in set A. Do 2 has got a pre-image in set A? No. So this is not a range. This also does not falls in range. This also does not falls in range. In other words, all those elements of set B has got a pre-image in set A will form an range. I hope you got it in a crude sense at least. Yeah. So this is something we understood. So now our domain, I'll just write down the elements and I'll take another example, then you'll be able to understand. What is my domain? 1, 2, 3, 4. What is the elements in my codomain? Same, 1, 2, 3, 4. What is my range for this function? The range is just 1. Okay. Now tell me, what is range for this? The answer is 1, 2. Now tell me what is range for this. The answer is 1, 3. Right? Now the answer is 1, 2, 3, 4. So how is this range changing? So range is again now when the elements in the codomain, all those elements in the codomain which has got a pre-image in set B forms a range. Okay, clear? Now we understood what is our domain, what is our codomain, and what is our range. Okay, so now if I give you a function something like this, and I also told you what is my domain here. So domain is all set of your x values, and codomain is all set of y values. And you know that range is nothing but what? Range is nothing but basically a subset of codomain, correct? Range is nothing but a subset of codomain. That means my range will be something, my y values, right? So if I have to write down, this is my 0, this is my 1, this is my 2, this is my 3, this is my 4, and this is 1, 2, 3.
Please mute, yeah.
Please mute.
Okay. So now you see, could you -1, -2, -3, this is, let's say, 1.
Hello, participants, please mute.
1, 2, 3, and 4. Okay, so this is somewhere here. Could you tell me, okay, now you see this is perfectly defined over here. There is no extension, okay, and this is also over here. So could you tell me what is domain for this function with this graph?
Domain is
-4 to +4.
+4 to +4.
Yes, and that is including
-4 to
right?
+4.
-4 to +4. And what is the symbol this says? That value is also included. Okay.
Yeah.
What is my codomain? Can you tell me what is my codomain?
-3 to +4.
-3 +4.
Entire y-axis, sir.
Entire y-axis.
Right. My codomain is all real numbers.
All real
I told you,
numbers.
right?
Oh, sorry.
What is my range
Yes,
here?
sir. 1.
Could you
-3 to
explain
+4.
-3 to +4? What is the purpose of a codomain? I mean, how does it help us? Domain and range are enough, right?
Yeah, that is fine. But if I restrict my domain here and I say codomain here, and then I say my codomains are only natural numbers, I can do that restriction. Here since this is number line, so you can have all R values. So it's all real numbers, right? Now, if I say in a question, like if I say a function f such that it is from real number to a natural number. So what does this mean? That means your codomain is all real number. Sorry, your domain is all near numbers, but your codomain can only be a natural numbers. This is what it means. So this is up to, I mean, this is just to give you an intuition like, okay, what is the set of, basically this says you what is your set B. It gives you a restriction saying that your set B is natural number over here. Okay, clear?
Excuse me, sir.
Yes.
Sir, over here, why can't we take the elements of x-axis also as real numbers as we took y? Why can't we take the domain also?
Okay, I'll tell you why. Because see, over here, I'm restricting this function. You see, this function has been restricted over here. And I say that if I was telling you like this, right? If there was an arrow over here saying that, okay, this goes from -infinity to +infinity, then the domain would have been a real number. But what I have done here, I have restricted this saying that, okay, your set A should contain only elements from here to here, right? And what am I saying here? Your codomain can be all real numbers, right? But what is the output you are getting from this set A? Now that is something falls your range, right? So range is all set of y values of which this is mapped, right? Of which this is mapped, isn't it? So now if you see, if this was your x value, so I could have written this safely -4 to -3, and this point would have been what? 4 to 4, right? So everywhere you see, in all this domain, you will see this kind of conditions coming in, right? A straight line. I mean, not a straight line, but you see that for all your codomain, or for all your domain here, you have a unique image in your codomain, right? And that you see from here, that is from -3 to 4. And these are only the values which it can take. That is from -3 to 4. Now, all those values you can write down here. But what is your about codomain? This is -4 to 4, right? So you see all these elements has gotten pre-image here, right? All these element has gotten pre-image. That forms your range. So you have it like this. Okay.
Sir, changing domain will affect the range.
So, but we can have on x-axis,
Yeah, definitely.
also we can have 3.5 a point now.
Sorry, x we can have?
On x-axis also we can have a point 3.5 and coordinately matching on y-axis as well.
3.5, yeah, you can have it. So you say like 3.5.
So the
you will have
when we are taking real number and natural number.
So the domain also consists of real number from -4 to 4. Is it so?
Yeah. I'm not no way saying it. It's in that, right? When we something write like this, it's all R. It's the real number, which includes all these. I mean between these. Okay.
So can we mean that always domain will be restricted and codomain is not restricted? That means it can have any values.
You can
from
do
which
that.
we can choose the range.
No, both can be restricted. Domain can also be restricted. Codomain can also be restricted. And since your range depends on your domain, right? So but that domain has to be a subset of codomain. The range has to be subset of codomain.
Sir, then the domain also cannot be unrestricted, no sir? It can also be real numbers like that, no sir, domain?
But see, in the question, what happens is whenever an examiner sets a question, he says like, okay, a function which is defined from, let's say R to N, as I was telling you here, all real number to a natural number. So what is the examiner saying? Your domain is what? It is taking it can take all R values, all real number values, but your codomain can only take natural values, right? And from this domain, now from whatever the function is given, then you see from this codomain data, what is the output values you can get. That output values from this forms your range. I hope that is clear.
Yes, sir. It depends on the function itself. Yes, sir.
Yeah,
Clear,
it depends
sir.
on the function. Okay. So now this is fine. Yeah, you're welcome. So now let's understand this. That is one way of understanding. Now I have another graph, something like a graph like
Sir,
this.
what if we change domain? That will affect the range.
Yeah.
If you change yeah, definitely. Okay, now this is a function given to you. Basically, this graph is given to you. Let me say this is some f of x. Okay. And this is for -4. Oh, sorry. This is 2 and this is some 4. This is, let's say, this is some. Okay. Let me say this value is some 3. Could you tell me this function f of x? Oh, okay, this is not, let me not say this as function. Can you tell me this graph? Does this graph represent a graph of a function?
No, sir.
Yes,
No,
sir.
it is not a function.
Yes, sir.
Yes, sir, definitely.
Yes, sir, it
Yes,
is.
sir. It definitely
Yes,
represents
sir.
a function.
No.
Yes,
Now I will tell you
No,
why.
sir.
I'll tell you why. All right. Now you see this. For this one, yeah, you see this. Now you have 2 and you have 4. Okay. And then you have another things. Let's say this was mapping to 3, right? Right? So you see what is happening here. This is fine. Correct. If you take this part, it says, yeah, this is okay. Now this is satisfying the condition of functions. Now try and understand with this. Oh, sorry. If this was 2 and your output value was 2 and this was 8. Now you see, when your x value is 2, what are the outputs you are getting?
2 and 8.
2 and 8.
Is this an unique image?
No,
it's
not any unique.
No, sir.
There is true value for.
So graphically, this is one way of understanding that Not all graph can be a graph of a function. Okay, not all graph can be a graph of a function. So just keep that
So,
in your mind.
sir,
That
if
is,
the
okay.
if the image is not unique, then it's not the function. That's it.
It's not a function. Yeah, exactly. So now, having known this, let's
Sir,
understand what is
can
one
be
to
a
one function.
Sir, one doubt, sir. One doubt,
the
sir.
previous
Yeah.
one
Sir,
which you
can we
said
say
is
y equals to the x square as our function? So can
Y
we
is
say
equals to x
y
square.
equals to x square as our function?
Yes, you sir. Of course. It is a function.
But if sir, if we put -1, we get 1. If we put 1, then we again get 1.
Yeah. But this is permitted, no? See, this is giving you an unique image 1, and this is also giving unique image as 1. What do you mean by unique images? Like, this should not be happening. This is not a unique image in your set B, right? Because when one is giving you two values like 2 and 3, this is not unique image. But the other thing
Okay, sir, got it.
Also, so does
Got
that
it,
mean
sir.
that a
If we say y
horizontal,
square is equal to
like
x, then it is
Yeah.
not a function.
Just a minute.
Sir,
Yeah,
sir,
what horizontal?
horizontal parabola is not a function?
This one.
You're right.
Yeah, exactly. This is not.
I see.
And
Okay.
sir, similarly, square root of a natural number will not be a function then, because it might have two possible values.
This one, root x.
Yeah.
Okay, so is it plus or minus?
Yeah,
Or it is just plus?
it's plus.
If it is just plus, the graph will be something like this.
So will it be a function? But it can have
Yeah.
negative. It can have negative.
You have to pay attention here. If you are giving plus and minus, then it is. You told plus. If it is just plus, then this is the value. If you say plus or minus, it will become like this.
Okay. So in this case, in plus and minus,
in this case, it won't be a function. In this case, it won't be a function.
Okay.
But
Sir,
when you just have,
not a function.
okay, you just
right?
take minus, it is still a function.
Okay.
So these graphical representations questions may also come, like if they give the graph and
No,
ask
not
us
in
to-
not immediately. Of course, like you have so many weeks ahead. Pay
Mhm.
attention for them. Not in your first week. I mean,
No, not
no
first
weeks.
week, sir. Like in this qualified 10th October exam.
Definitely. You might have.
We might have. Oh.
Yeah, you have another units coming up ahead. Like you have a straight line, then you have a quadratic functions, then you have polynomials, in which you have a graphing of polynomials. So you will have all that big things coming up. But you see, you have to learn graphs no matter what. And don't worry, we'll be there with you to teach all that.
Sir, one to one and many to one are function, and one to many is not a function, right?
Sir, please explain other.
You can generalize that with yourself.
Can
Okay,
we
so now
discuss
let's.
here later? Sir,
Can I
please
speak?
other condition for function.
There are only two conditions, right? You can see this video. What are those two? In that first statement, only two conditions were written. First, that all the elements of a domain should be mapped, should have an image in your codomain, and it should be a unique image. That is the second condition. Okay. So now let's go with the type of function, and I have to restrict now. Now I'll take for another 20 minutes because I'm getting.
Sir, what is the second condition?
Sir.
First condition.
Second condition.
It should have a unique image in set B. Yeah, that's all. Okay. So now let's understand what do we mean by one to. So functions, we understood what is functions and how this functions is different from a relation. That is something we understood. Now function is of two types, or you can say yes.
Sir, can we say that all conic shapes except for upper hand parabola or lower hand parabola are not functions?
Okay, so don't worry about that. We will cover that thing. There is something called horizontal line test and vertical line test, which you will be studying in this Maths 1 course itself. We will explain you all that. How to, when the graph is given, how to understand whether that is an 1-1 function or 1-2 functions, or like whether it is a function or not. But for time being, all that you have to keep in mind is just make sure that the definition is being fulfilled. Okay, so now it should, as I told you, it should have a unique image, right? So this kind of cases should not be happening, right?
Yes, sir.
Okay, so now function, it is of two types. One is injective function, another is surjective, right? So this is also called as 1-to-1, and this is also called onto. So what do you mean by one-to-one function? So I'll just do it here. One-to-one means, so there are, you can understand with one mathematical notation as well, but first understand with your arrow diagram. So now if I have 1, 2, 3, so and another I have 1, 2, 3 here. So what does injective function says is, now you should basically you should see you can have these conditions coming in here. That means if I can put it in a different way, saying that, okay, a unique image in the domain should have a unique image in the codomain. So you can understand this in a crude way like this, okay? So now that is one way of telling it. Now, let's give it a minute. Just give me 2 minutes.
Okay, sir.
Yeah, I'll come. Just give me 2 minutes.
Yeah.
Okay, sir.
Hello, class.
Hello, class. Hi. Hi, everyone.
Agorapur?
Yeah, hello? Yeah.
Yes.
Yeah.
Hello.
Hello, sir.
All
Yes,
right,
sir.
all right, all right. So I'll mute everyone
right, sir.
again, and then I'll start. And I'll give another. We can just wind up this session in another 15 minutes. I'll just complete what these functions are, and then you can do your assignments by yourself. If you have doubt, you can put it in the forum. We'll take. Okay.
Okay, sir.
So put it in the forum in sense where, huh? Like email.
Discourse.
Form.
Yeah. Google
Sorry?
Form. Google Form.
Discourse is the
Oh,
forum.
okay.
Okay. So please mute yourself. Okay. So now injective function, one-to-one function. So here, what does it, in a crude way, if you have to understand, distinct element of A, of set A. So this is some kind of mapping. Some kind of mapping is done. So under some, some F mapping, like this is some kind of mapping we have done. F mapping function has one distinct image. So that means this also has to be distinct, and here also it has to be distinct. This is all it means. Okay. So now, having known this, okay, so let's try and understand some concepts here. So now if this is 1, 2, 3, and here also 1, 2, 3, and there is some, now this is A to B, and there is some kind of mapping over here, and this is a mapping done over here. So could you tell me, put it in a chat box, okay? Could you tell me, is this one function? Just
No.
put it in a chat box.
It is
Put it in a
not
chat
on,
box.
sir.
Put it in a chat box. I'll give you the explanation. The answer is no. First of all, this is not a function, right? So there is no concept of 1 coming in here, because you see this element has no image there, right? So first of all, this is not at all a function. So that itself is gone. Now, what about this? Put it in a chat box. Is this a 1 function now? This is definitely a function, but is this 1 function?
No.
Most of you say no, it is not. Why? Because distinct element
It is a
of
many.
A under some mapping should have a distinct image, right? So you don't have a distinct image here, right? You see, this has got 2 pre-images. This is not distinct anymore, isn't it?
So,
So
but,
this is not happening.
but it is a unique image. Hello.
Okay. Yeah.
I'm saying, sir, it is a unique image. What you said previously.
Okay. So here, distinct element should have a should have one distinct pre-image. Okay, distinct image here. Understood? I'll mute everyone again.
No, sir. Please mute.
So if you're getting confused with what we have told earlier when we were defining a function and we were telling like, okay, if this was 1, 2, and then this you had 1, 2, 3, let's say, and I was telling you here what you were saying here, if this is my image, let me say I use a word image here and I use this as pre-image word here. Okay. So now you see, for it to be function, it should have a unique image. Now you see this is unique image, right?
Yes, sir. It's a unique image.
Right? It's a unique image. Now coming to this part, distinct element of A, set A. Now here I was giving you a condition, something like this, okay? Right? Should have a distinct image here, right? So now you see that, okay, now you can say like, okay, this was giving me this was giving you an unique image, right? And this over here. So in other words, if you are having difficulty to understand here, so what you can do is, now here all these elements like which are mapped here should have a unique pre-image. Okay. Now that is fine.
No, sir, still not.
I'll clear again. Now if this is your set A, 1, 2, 3, and this is your 1, 2, 3. Now see, this is, call this as pre-image, so call this as image, and this as pre-image. Now a distinct element of set A should have a distinct image in set B, or let's say it should have a, okay, this is not happening, right?
This is a function.
This is not 1-1 function.
This is a 1-1,
Okay.
sir.
Sorry?
It is
I'm saying, sir, this is a
function, but it is not 1-1.
This is not 1-1 function.
How, sir?
I think the confusion is between the word distinct and unique.
Okay. So okay, fine. So if you have a confusion with that
Please
word, so
explain
what
this.
you can understand here is any elements over here as well. Any elements should be mapped uniquely to any other element in another set. Okay. So now you see this set. If you see this element, it should be mapped uniquely to any of these, any of its pre-image. So is it uniquely mapped here? No. Right? Okay. So if you have a function has one distinct, take it as pre-image, set A under a mapping F has one distinct image in set B, or you can say it as mapped element of set B should have unique pre-image in set A. Now it should be fine. Okay, clear? So this is 1-1 function. Okay. So all you have to do is
This is 1-1.
this one is uniquely mapped to the other one. It cannot have
This is
this
1-1.
thing happening, and definitely this cannot have, because this will not be a function anymore, right? So this condition
Yes.
should not be happening. Okay. So
This
now
is
having known,
just a second, sir. Sir, if you say that 1-1 is there, I mean 1 is mapped to 1, and you say 2 is also mapped to 1. So this should be many one or many one function.
that you can say many one or one to many, these kind of things. That is okay. You can use
1-1,
those words.
but it is not 1-1.
This is not 1-1. 1-1 means
Okay.
1 to 1. I mean, you're just getting one input, one output, like that.
So we can
Okay.
say it simply so that no two elements should belong to the one element in simple words, right, sir?
Yeah, you can say that.
Yeah.
So clear? Okay, so
Okay,
this is
sir.
one way of saying it. Another way of saying it as, when you use it, this mathematics way of saying, if f of x1 is equals to f of x2, then x1 should be equals to x2. Okay, so that means if this is mathematical notation for saying if for 1-1 function, if f of x1 is equals to f of x2, then x1 must be equals to x2. Okay, so if you have it 1, 2, 3 and 1, 2, 3 here, so this is nothing but your f of x and this is your x, right? And there is a relation from here. Now it says what? If these two are being equal, I mean, let's say this is your x1, x2, x3, okay? If f of x1, now this is your f of x1, correct? F of x1 is 1.
Yes, sir. Yes, sir.
F of x2 is 2. F of x3 is 3. So now you see, now when we say that here x1, x2, x3, now you see that if this is happening when f of x1 is equals to f of x2, when are they equal? Any of these are equal here?
No.
They are not equal, right? So it's just in a simple way you can say that if f of x1, so this has to be uniquely mapped. This is what it means. So it will be crude to understand. Now if I give you an example and if I say y is equals to x, okay, so now for in this case, if this is your x and this is your y and there is some kind of mapping, so if I give any value of x, you will have a unique output here, right? 2 for 3 you will have 3, for 4 you will have 4. So these kind of things happening. Yes.
Sir, if codomain has more values which do not have any pre-image, is that a valid one-on-one case or no?
Could you repeat again?
Yeah, if the codomain does not have like extra elements which do not have a pre-image in domain,
okay,
will that be a valid one-on-one?
Yeah,
that will also be a
yeah, that will be.
Okay,
so
that is
for
about
example 1, 2, 3 and 1, 2, 3, 4. So domain is 1, 2, 3 and codomain is 1, 2, 3, 4. So that will be a valid injection. Okay, one-on-one injection. Okay.
Yeah, this is one string.
Okay.
Okay, now let's understand. So this is all about this. So as you do numericals on this, you will be able to understand it better. What do we mean by surjective here? When range is equals to codomain, then it becomes
mathematically again.
Mathematically again, is it? Okay. Now if I take y is equals to
when
x
all the values of codomain is matched with range.
Okay, I'm still on 1 function. I'll just finish this and then we'll take. Now this y is equals to f of x square. So this is my x, this is my y. Okay. So now if I give it, let's say -1, 0, and then I give it as 1, and so on and so forth, right? And over here, you see what do you get output? When you give it -1, what do you get? You get 1 as the output. And when you give it as 1, you get still 1 as the output, right? So we understood that this function is not 1, 1, right? This is not 1, 1. So, okay, pictorially we understood this. But how do we understand this? When you use this mathematics form. So when you say if f of x1 is equals to f of x2, then x1 should be equals to x2, correct? Now you take this value.
Yes, sir.
F of -1. What is f of -1?
1.
1.
F
what
of
is
1?
f of 1?
1
is 1. Now you see f of -1 is equals to f of 1, correct?
Yeah.
Yes, sir.
If this is happening, then this should be right. Is this happening? Is -1 equals to 1? It is not equal.
No.
Therefore, it is not 1.
No, sir.
Not 1, 1.
Okay, understood.
Sir, Srishant,
Okay, now let's. Yes.
Yes,
I didn't get that example.
DOM of given like DOM of f is equal to DOM of f
Domain of f
is equal to x belongs to R and f of x belongs to R, sir. X
belongs to odd.
Yeah, or and or real numbers, all real numbers, or.
Okay.
And f of x also belongs to real numbers, sir. Codomain 2.
F of x also belongs to real number. Okay.
So, sir,
so basically your f is from R to R.
R to R, yes, sir. So under this condition is in root under 10 minus x injective. That's what my doubt is.
Is root under 10?
minus x, root under 10 minus x. 10 minus x, root under 10 minus x. 10 minus x.
Is
Yeah.
injective or not, you're asking?
Yes, sir.
Yes.
Because
what is sign over here? Plus or minus what?
Yeah, plus, sir.
Just plus.
Yes.
Okay. So if this is the case, then you see, is this injective or not, right? This is what you're asking, isn't
Yes,
it?
sir.
So here I'm free to take. So you see here, you first need to find out the domain here. Right?
But we cannot take real domain.
Yeah, you cannot take all real domain here.
Yes, sir. That's what it was. If we can't take all real domain, that this is not a function also. We can't define it as a function, right?
Yeah, exactly. Do you see anywhere in the question like this?
Yes, sir. Yes, sir.
Which question it is?
It's an activity question, sir.
Okay, so I'll take a look over it.
Yes,
so,
Sir, I think the domain is not defined for this function, sir. So the real
No,
domain
sir.
can be applicable, but it's not defined for this function.
It's given in the
It will
question,
not
sir.
go. It will not go after 10.
Yeah, so basically, so that
That's what I
you have to make sure that this is greater than or equals to 0, or
0.
it is greater than or equals to x.
More than 11
So,
will not defined.
So you can only have those values. So what will be its domain? So its domain in this case, it's going to be right.
Minus infinity to 10.
Yes, sir.
Something
Yes,
like
sir.
this.
Yes, sir.
Yes, sir. Yes, sir.
Okay. Okay. Now let's go with next one.
Yes, sir. For the question,
subjective
it's given as injective in the activity question, sir. That's what I asked.
So then I'll have to look for that.
It is injective.
I guess. Yeah. So I'll have to look for that. I'll just check once.
Yes.
Okay. Okay. So now here for subjective function, when range is equals to codomain. So when do we say when range is equals to codomain? That means if all the elements of set B, if all the elements of set B has got a pre-image in the set A. Okay, clear? So that in that case, your range becomes equals to codomain, right? So yeah. So how do you see that then? So if I have to tell this with an arrow diagram, if I say 1, 2, 3, and again here 1, 2, 3, or let's say 1, 2. So is this an onto function?
No.
No.
1, 1.
No, sir.
No, sir. No,
No,
sir.
it is 1, 1.
This is 1, 1.
Not equal to code.
But this is not onto.
Not
But this
onto.
is, because 3 has got no pre-image here.
Yeah.
That's
All
why
the
it is
elements
not
of codomain should be used.
Yeah, all
in
the
this
elements.
case.
Yeah. So when see here, is range equals to codomain? No.
No,
Right?
sir.
Because what is
No,
your
sir.
range
No.
here? Range is your
1, 2,
1,
3.
1, 2, 1, 2.
What is your codomain here?
1, 2, 3.
And these are not equal, and therefore this is not an onto function.
Onto
Okay.
function. Okay.
Okay. Okay, clear. So now this way you can understand this. Now I'll give you an example. So this is pictorially we understood. Okay. Now let's say I have a function such as my function is defined from natural number to natural number. Okay. And now I give you this thing. I think you have it in the activity question only, this question.
Yeah.
So you have n plus 1 by 2 if n is odd, and n by 2 if n is even. All right. So now how do we do this? Is this 1, 1 function? Is this onto function? So since you would have already gone through activity question, you might give the answer.
Sir, it's on.
This is not a 1, 1 function, and this is not even a.
Not a 1, 1.
What does my element can contain? It says from natural number to natural number. So it can have all those elements, right? So 1, 2, minus 1, 1. I can say 2, 3, and blah blah. So this also goes like this.
So anyone
over
onto.
The natural number starts with
But it says natural number, so
Zero.
it should be 0
Natural
to
number
infinity.
0 to infinity.
Thanks.
Not
Natural
1.
number starts 0.
Yeah. Thanks for pointing out that. So it goes up to infinity. Okay. So now, okay. So let's start. When n is odd, you use this, and when n is even, you use this, right? So, and this is your x, and this is your f of x, and this is a mapping, right? So, and this is mapping from natural number to natural number. Now you see this, when n is equals to 1, what do you get? For n equals, okay, for n equals to 0,
1.
what do you get?
0.
0.
You get
One.
0, right? So
Because
this is
0
mapped.
is even.
Yeah, so this is mapped properly. What about 1? For 1, what do you get?
1.
1.
For 1, you get 1. What about 2?
2, we get 1.
1, sir.
1, sir.
Okay. So now you see something here. Is this, first of all, is this 1, 1?
No.
No, sir. Many one.
It's
Okay,
many
fine.
one.
Many
No,
to
sir,
1.
it's not 1. It's many 1.
Let's
Not 1,
understand if it is onto or not. Let's take 3. So when you take 3, what is the value?
2.
Okay. What do you get? 3. For 3, what do you get? 2.
2.
What about
So it is
4?
on to.
4, 2.
2.
So likewise, when you go up to infinity, what do you see? All your elements over here will be mapped, right?
Range is equal
Yeah.
to code.
Codomain.
I can
So
say
it's
that
an
this is
onto function.
So it is on
It's an
2.
on to function.
so we understood this. All right. So I
Yes.
think
Sir,
this is.
excuse me.
Mhm.
So I think it is not an onto function as well.
Why?
How?
So because if we have set A and set B, both are equal because they are up to infinity. So there will be always a number which is left in the codomain.
But the moment you try to list that, right?
So we will add one more number to both the sides.
Yeah, I get your point. You're saying when you go up to infinity, there will be infinity plus 1.
Yeah.
Yeah. So that is not the case. When you say infinity, it's infinity. You are not adding anything to infinity. Infinity plus 1 will give you infinity only. So you don't really have to, you have to really consider that as infinity.
Okay.
Sir, but if we change the codomain to real, then it will be not on. No?
Yeah, of course, it won't.
Sir, one question, sir.
Yeah, it won't be.
Sir, fx is equal to mod x plus 4.
Mod x plus 4. Okay.
Then
now is
4,
this
no, sir.
1, 1 or no?
No, sir. One more part. And another bracket 4x minus 10. Then mod close.
Sorry. Okay. X plus 4.
X plus 4. Then
Bracket
4x minus 10.
4x minus 10. Okay.
Mod close.
So we have to.
X plus 4 will also be in brackets.
X plus. I didn't get it. Have I written it properly?
Both
No,
the
sir.
expressions are in
Sir,
there.
fx is equal to mod
X plus 4
bracket.
into 4x plus 40. 4x
He
minus
wants
40.
to make it
Plus
quadratic.
4. X plus 4.
Into
Both are in brackets.
In bracket.
Okay.
4x minus
Okay.
10.
Yes, sir. Yeah. No.
4x minus 10.
Yes, sir.
This is also
Is
Right.
it,
So okay.
injective or surjective? On one of
Okay.
these.
Okay. We'll see this. Okay. First of all, let's understand this, whether this is 1, 1 or not, and whether this is onto or not. You know what is bijective, right? If it is both, then it is bijective.
Yes.
Yeah.
Correct?
Yeah.
Okay. So now let's understand this. First of all, you know this mod function. How does the mod function graph look like? Something like this, isn't it?
Only
No matter
positive.
what x value you give,
It
it will
will be
only give you
positive.
positive y, right?
Yes.
And what is this function defined from? Is it defined from R to R?
Sir, just a minute. Yes, sir. It is defined from whatever.
R to R. So clearly you see this. If this is R to R, but output, what do you get? Only positive values, right?
Yes.
It will not be mapped for
Yes.
these values, isn't it?
It is not R to R, sir.
It is not 1, 1. Sorry, it is not onto.
So not on.
From R to R positive.
R to R positive. Okay. So you mean you can take all R values over here and you can only take positive R values, right? Okay. So let's try and understand this. Okay. So what happens when x is equals to when what? Okay. So when you have something like this and this is already factorized. Okay. So you take this value. When can this become? You take this value and then you see that x plus 4 equated to 0. Can you tell me when will these functions become 0? So if you take x equals to minus 4.
X
At minus 4 and at 10 by 4.
And x.
And when you
10
take
by
this
4.
as 10 by 4, that is 5 by 2, you will still have what? This is mapping.
0.
This is not.
0.
This is not for
This is not what? This is not
1, 1.
1, 1.
1, 1. Not 1, 1.
Okay. What about onto? So this is definitely not bijective. What about onto?
If
It is
the
on 2.
if
It
codomain
is
is
on 2,
R
right?
plus, then on 2.
It is on 2, sir.
Yeah,
It
exactly.
is
So I
on
think
2.
you know. So all of you know this. All right. So I think we can wind up the session right now. And like, if you have any more
Yes, sir.
doubts, we can take it in the forum. All right. I think this went really lengthy, but this is something will not be happening in future. So thank you everyone. If you have further doubts,
Thank you, sir.
PDF
Thank
of
you,
what
sir.
this we have
Thank you,
arranged
sir.
it already. I don't think we need a PDF for this. Thank you everyone.
Thank you, sir.
Thank you very much,
Thank
sir.
you.
Thank you, sir. Thank you very much.
Thank you, sir.
Thank you all.
Where can I
Dhanyawad,
find
sir.
your forum?
Dhanyawad.
Sir,
Thank you,
today's
sir.
lecture was very nice, sir. Thank you very
Thank
much.
you, sir.
Thank you, sir. It
Sir,
was
will
very
you be
nice.
taking
Thank
our
you,
today's
sir.
statistics?
Thank
Session
you.
was amazing. Thank you.
Sir.
Not me.
Thank you,
Somebody
sir.
else will be taking statistics. All
Okay,
right.
Sir, I
Thank
have a
you.
doubt.
Okay, sir.
Thank you, sir,
So you
for
still have a doubt? We'll take it in the
Yeah.
forum.
Thank you, sir.
Sir, I have a doubt.
Tomorrow we'll have a session again.
0 is not an odd number. It's an even number.
Thank
Thank
you,
you.
sir.
Thank you, everyone.
Thank you, sir.
Sir, we
Thank you,
can
sir.
leave
Thank
now.
you, sir.
Thank you, sir. Yeah.
Yeah. Definitely you can leave.
Excuse me, sir.
Yeah.
Will this class happen every day?
No, not every day. I mean, thrice a week.
Thrice a week? Okay.
can you please
Sir,
share
check your Google
So when
Calendar.
will the exam happen for the session, sir?
I think it will be happening.